Am I very late? Yeah. But if you look at this differently, I'm not 3 hours late. I'm actually 4 days early because I normally stream on Wednesdays. So we'll go with it. Don't be too mad. Actually, I have to fix something on my setup. One sec. Cam, right click, full screen projector. There we go. Now my setup's how I like it again. Yes, late is relative. I like how you guys think. Let me pop out chat quick. Thank you to YouTube chat as well. Sorry I was so late. Thank you for everybody who has been resubbing as we get started. Oh, did Tanner write a blog post about the directive stuff? Well, thank you, Shavam, for the resub and immediately dropping useful resources. I always appreciate you, man. Fucking legend. Speaking of which, M27 of Legend, thank you for the 6 months of support. Appreciate that a ton. No Axe with the 5 months, and Insanity later with the 42 months. Jesus Christ, you guys have been around too long. Oh shit, low level. How you doing, man? Advent of code's only going to be 12 days long. What? 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 This is the end of an era. Oh man. This is a huge change. I won't lie, it's slightly heartbreaking. Has he posted about this? For a bunch of reasons, that's the right call, but it's still heartbreaking. I'll try to sneak to universe. That's good to hear, NMG. Yeah, I'll ping Discord. Good call. Thank you, chat. Everyone live on a Saturday, nerds. Done. Thank you all. No, I like for me, I see Advent of Code and like the difficulty ramp not as like it gets too difficult too fast, rather. Oh, this is actually a really useful source. Thank you, chat. I see it more as like the first few days are just like getting your brain thinking that way again, and like a fun way for people who aren't into that type of thing to discover it, because otherwise they might not. So I see it as like a fun thing. But also I get it. Cause like the reality is that Advent of Code isn't for everyone, but most devs should aspire to be able to do it. So the first few days getting you like into that type of thing, and from that point forward, it just kind of becomes really hard. That gave me the incentive to like want to level up so I could do that. Yeah, not numbers great. They haven't posted in a while, right? Yeah, this is the first time they've posted in a very long time. This is something I'll definitely read later. You guys are loading me up with good sources. Appreciate y'all for it. Our RSC's a mistake. Drop that in there. This is the only priority thing we have. Author follows me. I'll follow her back. Least I can do. I have no reason I would recommend these languages, but like if you really like them and they solve problems you have, that's fine. Like I'm not against them. Thank you, Noax, for the 5 months of support. Insanity, I think I already got you for the 42 months. Chats with the 5 bomb. I don't know how I missed that. Thank you so much for the gifts, man. Really appreciate that. Then PQO with the 12 months of support. Oh, God, what's Fred saying? I'll throw that in here. Why not? Oh, God, there's so many links today. My cats are fighting aggressively. Once. Sorry about that. I think I'm the only one home and the cats are being a bit aggressive. Open router. Oh yeah, I saw this was a thing. Very much like it. I think I put this in already. Oh, I've not. I'm waiting a tiny bit more before doing like my tan stack deep dive, but I do plan to in the near future. Thank you, Erdaltop, for the prime as well. Yes, I use my K400. I love it. Rest in peace. Working with some companies to see what a future of something similar would look like. Just really want it to continue existing. And if I have to like pay a company to manufacture something similar, I will. Yeah, I'm sorry, chat, that I've not been checking YouTube as much. Yeah, music and computer science are my degrees. Doesn't really matter. Headset's a loaded word. This is in one of the bookmarks, I believe. This one. Yeah. Yep, same link. Cool. Let me see if I can find Vercells. Okay, the Ship AI opening keynote is here. I haven't watched this yet, so I'll put that in the list as well. I also haven't watched the Next.js Conf opening keynote. Yeah, I know Ricky's been spicy. I know that's not the one where that goes. That goes here. Cool. Oh, this is a huge change. This is going to make my Synology a much more exciting thing. Fun. I'll definitely read Tanner's blog. Don't worry. 2 months, 2% of the way to 100. Appreciate it. Thank you, Raphael. As well as Mappa for the 5 months of support. I'm familiar with Tsoding. He's a very specific type of dev that like is really, really talented at the act of writing code, but has like decided that he's more interested in writing code than understanding the ecosystem. And his interest is much more like, how good of code can I write? And that's awesome. We need people like that. But there's a big difference between someone like him or a Jonathan Blow and someone like me, where I do love coding, but I am trying to be productive with it. Like my goal is always to ship real software people can use. They're in it for the art and the love of it just as much. And I'm sure this is going to end up a clip that goes to them that they talk a lot of shit on. But the point I'm trying to make is that like we have different tolerances for different things, and our goals are very different as well. And yes, ingest, temporal, and trigger will all be involved. Cool. Let me do my offset marker real quick. Marker off. Set 2445. Cool. I'm way too busy right now. I really wish I could because the HF0 house seems really cool, but I am too busy, Martin. I appreciate the invite. Also, I've seen the guy that's jailbreaking LLMs. I haven't had a chance to look into it just yet. I've been, again, just fucking disgustingly far too busy. I'm so tired. I am so excited for 2 weeks from now where everything finally calms down when all the conferences are done. Better experience writing code should correlate with more product shipped. At a certain point, when a thing becomes fun enough, it becomes a game. And games aren't necessarily productive. Like, there's a line that gets crossed for sure. And the spectrum is complicated. I think going to college was really good for me, just meeting peers and having people to pace myself against and having like these connections that are so essential to my success and my career, my life as a whole, but the degree itself, less so. Yeah, Twitch is the main platform for my live streams. YouTube chat's just kind of broken. Oh, it's Mistral cooking. Oh yeah, I saw the AI Studio thing. I genuinely don't care. Like, no one's using it. People, like, the point of Mistral is not to be a useful alternative. It's to feel enough like one that people talk about it. Drop my tea bag 1 sec. What's the plan for stream? Great question. So the reason that Mistral models aren't on T3 chat is specifically because the models can't be as fast as they are on their platform because they arbitrarily restrict who has access to the fastest infrastructure for the models. Despite being the open model company, they are the literal only provider that I know of, and I know most of them, that has their models that are supposedly open, which they're not. They haven't done an actual open weight model in a long time. But they only provide those models on fast infrastructure for their own chat app. So if you were to compare the speed of Mistral models on T3 chat versus a competitor, their own app, theirs would be 50 plus times faster. And then we're going to get a ton of support tickets. Like, why is Mistral so slow on T3 chat? And I'm not fucking dealing with that. So sorry. If they're going to beat negative players in this space, I'm not going to support them. I can't possibly check random things in Discord midstream. I'm sorry. I need to get filming. The main priorities today are the used drama. RSCs are a mistake. Maybe we'll do the Cloud background agent stuff. And then some of the like pile of vibe stuff here. Let's dive straight into it. You know what? I kind of want to watch their thing first because I haven't yet. Let's watch this together. And then I'll start filming. So I want to hear it from their words.
But the world is moving from pages to agents. The industry is moving so fast, it felt obvious we needed this conference. Because we've seen this movie before. It's 2014, you're sitting down to make your website on astrophysics, your favorite subject. You've got this great idea. You start coding locally, as one does, but it felt simple. Drop in a specific models API, give it a prompt, get a response. Because we experienced it ourselves. At Vercel, we use Vercel to build Vercel, right? And we're going through the same AI transformation as every team. Awesome. Raise your hands at home as well. You can start building your apps using the AI SDK today. And if you know Python, this all sounds a little amazing and theoretical. The problem is that agents are a very specific kind of workflow. And so no matter what they do, they generally follow a life cycle when running that we can describe as follows. First, an agent accepts prompts. Then it intelligently reasons with context and plans to some extent. Then it acts through tools, repeating steps as needed. Sometimes this is an actually fixed sequence of events, which is desirable for areas like finance or other places where structure and guardrails.
I know this is the AI one, not the Next.js one, but we're not talking about Next just yet. I want to talk about the used workflow stuff, which is in this, if I recall.
Rails and predictability are essential. And if you look at this workflow, it kind of looks like you could design this visually, right? It looks like a bunch of nodes that are connected, and there's tools today to do this, right? There's low-code, no-code tools to do this. And that might be good for prototyping, but it can also be brittle. It doesn't have CI/CD attached to it. It doesn't have deployment previews. It's hard to think about how it scales. It's hard to observe. There's no version control. It's a pretty big one. But ostensibly, right, this is the next generation of software. This is what your entire businesses are going to run on. It needs production-grade infrastructure and engineering. So I believe that engineering is what's going to make the difference. Because great engineering gives you both a structure and flexibility, the discipline to scale, and the freedom to
great at writing React components. We wanted to take advantage of this without having to maintain multiple different SDKs. Finally, and the most nuanced point of all, building on top of language models presents fundamentally new challenges for building both reliable and type-safe UIs. We don't know exactly what they're going to generate, and with streaming, we're only getting small chunks of that at a time. So we built the AI SDK, a TypeScript toolkit for building AI applications. With the AI SDK's unified API, we didn't just add features, we rebuilt the entire library from the ground up. For the first time, you get end-to-end type safety from your LLM to your UI. No matter what the model generates, whether
I'm proud I took a meaningful part in bullying them into doing this.
it's text, reasoning, or tool calls, you can build type-safe UIs on top of it. We also gave you more control over your context. We now explicitly decouple your application state from what you send to the model in each request. This makes it easy to control every single token you send. Finally, we ship primitives to give you control over the agentic loop itself. As G said, agents.
It reviews your PR and determines fixes. Your app is, of course, automatically built and deployed and protected by a multi-layer firewall. And today, we're introducing, hold the applause for this one. Today, we're introducing a native Python SDK. And this makes it, you don't need to have a provider account. You can use a single Vercel API and a flat memory charge. This is true serverless compute for the AI era. Now let's look further at tool calling. It's 2025. So what we really need, so to solve this problem,
Here's what I'm
today
here
we're
for.
combining the world of serverless functions with
Thanks so much, Aparna. Yeah, it used to be that you would just make one request to an LLM and kind of hope for the best. But like Aparna said, agents are starting to get smarter. You now have to reason and make tool calls, talk to an MCP server, maybe respond to external events and wait for human approval. But as agents are getting smarter and run for longer, the infrastructure to put them into production is getting really complex. You've got to manually wire up all of these queues and add a database, add up resiliency and maintain observability. But like G said, we've seen this movie before. Companies that we love have faced challenges scaling into production. So take a company like Uber, for example. When you request a ride, you've got to find a driver and calculate pricing, talk to a data warehouse and a payment processor. So companies like Uber put each of those steps into their own microservice. Great, but what's next? You now have to wire up all of these queues and add a database, add resiliency, and maintain observability once again. These challenges aren't unique to agents. We've seen this before. And managing all of the infra is just a lot of code, a lot of very brittle code. But what if it wasn't? What if all of the complexity of orchestrating microservices across the internet to request a ride, or the complexity of running an AI agent that's got tool calls and MCP servers and responding to external events, what if all of that was just a single function? We've managed to compress all of the complexity of durable execution into a single line of code. I'm really excited to announce the workflow development kit. It's a new open source framework for building durable, reliable, and observable apps and AI agents in TypeScript. I'll show you how it works. I'm going to take the same agent that Nico built earlier, and we're going to wrap it with use workflow. This effectively lets the entire function be durable. And so we were inspired by Next.js's directives with use workflow, but we've built this to work across every framework. Use workflow lets the framework know that my function might suspend and run certain steps in the background. It's kind of simple, but this feels like a superpower, right? I can now write a function that splits work across multiple different processes, and you're not tied to a single process. It's effectively what microservices are. Now, to split up the work, I'll need to define steps. And as you can probably guess, we have another directive, useStep. useStep lets you mark functions in... You can probably guess we have another directive, useStep. useStep lets you mark functions in... useStep lets you mark functions in your workflow that need to run in the background. And for AI agents, most of the work of making a request to an LLM and executing tools. So I'll start by making each tool a step. And I do that using useStep. Simple. Now, the workflow dev kit compiles every single step into its own API route so it can run in the background. Back in my workflow, I'm going to update the tool call to use my new steps. This way, when the agent calls a step, the tool gets run on a separate API route in the background and uses a queue in the middle for resiliency. Cool, now my workflow is all set up, and I want to execute this. During execution, every time the workflow encounters a step, it's going to suspend the workflow and run the step in the background over a queue. If the step fails, it automatically gets retried, so it inevitably succeeds. And when the step is done, the framework can resume right where it left off, rehydrating state from the event log. This means you can just write one single function, and you don't have a long server. There's no long-running servers, and you don't lose all of your tokens if a single step broke. This is what orchestrating complex microservices wishes it could be. Also, thanks to the same event log, all your workflows are observable by default. which means you can now inspect every run, every step, every LLM call with world-class observability, and there's no extra code. This just comes built in. This is what LLM tracing really should have been. The workflow development kit is open source, and we're building it to work on any cloud platform. If you do deploy to Vercel, Vercel will automatically provision the right resources needed to run your workflows with zero configuration. On the AI cloud, your workflows run on scalable functions made efficient with fluid compute. Also, since every Vercel deployment is atomic, you get versioning for free out of the box. This means you don't have to worry about breaking workflows, some of which might be running for months. You can just keep shipping.
That part is a big deal. The fact that like
sometimes there's an agent as a service.
If your like background jobs like shape changes, but you have an old one that's queued, it would just break. That's one of the things I thought about. In some ways, it's foot gun, but I also think it's like really powerful, especially if they make good enough observability into it. But like the observability is the key there.
It's perfect for what you need. That's why we're introducing the agent marketplace for AI agents and tools built for the Vercel ecosystem.
Okay, I could literally not give less of a fuck about yet another marketplace for AI stuff. Okay, I don't care about any of that. I'm here for the workflow stuff. Okay. Think I have a good enough vibe on it. I know how I want to talk about this, which is usually enough. This one's gonna be one of those videos where I piss off literally everyone, including the people who I'm defending, so to speak. This will be fun. Yeah, I have all the analogies I want to make in my head already, which most of these are going to piss people off, I can tell already. I do want to see a bit more of like syntax. Like when I define a step, what does it look like for retries? By default, steps retry up to 3 times on arbitrary errors. You can also use their fatal error helper. With a retry after, ooh, that's actually really nice. Okay. Okay, I see the light. Okay. Okay. Let me get to the...
Mark.
No, perfect. Ah. Okay, I think I have everything I need. Let's do it. Thanks, Dev, for the sub. Glassy's 41 months. Jesus Christ, good to see you, man. And Maul with the 11 months. Appreciate you all a ton. Let's get started. Marker. Use drama. Sorry, man, we gotta film a video. Yo, Shindigs with a 5 bomb. Thank you so much for the gift subs. Appreciate it. Ah, okay. So my thought for the intro for this is just screenshot all of the people who did like use Cloudflare, use Convex, all those things on Twitter, and just go through like a bunch of those flashing on the screen until we cut to just me. Yeah, you get the idea, Face. Let's do it. Use client, use server, use workflow, use step, use Convex, use Cloudflare, use Vercel. What's going on with all of these directives? There's a big drama cooking as okay, how do I want to... Nice pun. Shindigs. Anyways. In the right spot. What's going on with all of these directives? Why is everyone freaking out? Well, as usual, it's our favorite stirrer of drama, Vercel. They just announced the Workflows SDK, and everyone is getting upset because of this particular slide and what it means. Directives are here to stay, it seems. If you're not familiar with directives, it's a string that you put inside of your JavaScript code that is used to indicate specific behaviors. These started with the classic use strict, which was a way to try and change some behaviors in JavaScript to deprecate some not so great things and let you as a developer opt into the new behaviors. It hasn't been used very much since then. Vercel's kind of commandeered this alongside the React team in order to sneak behaviors into the framework. Like, the big case for this is client and server components, where you're dictating what code runs where. Use server is a way to say this function runs on the server, and when you call it on the client, it's effectively an API call to the server. And use client says this code and the code in this file should be bundled up and sent to the client so that it can run there as well. Oops. So what are use workflow and use step? These are attempts to make more durable executions for your JavaScript code, which is a very exciting thing. And I can't wait to tell you more about it, but first we got to use sponsor. I'll be right back. Actually, I can't wait to tell you more about it, but first we have to use sponsor. Perfect. That'll be fun. Anyways. There are going to be a couple steps to this one today. Pun not intended, but we'll go with it. A few things we're going to need to talk about as we go through. First, of course, what is the Workflows SDK? 2, what other options exist? And of course, number 3, why is everyone so upset? Because a lot of people are upset. From Tanner, in particular, Tanner Lindsley, who, as you guys know, is a good friend and one of the smartest people I know. He has feelings, and I actually don't think I agree. He did write a blog post, which is one of the many things we'll be going through. I have a bad feeling this is going to be a long video. If only it was broken up into steps. So let's start at the top level of what the hell are workflows and what is this workflow SDK? The simplest way I can put it is it's a way to take a function in JavaScript and break it up into pieces that can rerun over long amounts of time and execute in ways that you wouldn't normally execute a function. Traditionally, when you write JavaScript, it goes line after line after line, calling whatever functions you have inside of it, and it will probably hit things throughout, especially if you have a lot of async await calls. Like, what happens if this fails? What do you do? Do you go up a level and retry the whole function? Because, like, we got the user fine, we generated the email fine, but then the send failed. Do we retry at the top level and go through it again? Do we maybe write send email in a way where it retries itself 3 times? What if we wanted to send another email a week from now? There are so many things that are hard to do when you have these workflows that have multiple things going on in them that might not even be part of your own service. Like in this case, your get user comes from the database, generate email might come from an LLM or an agent or a series of agents, and the send email might be a third-party service like resend. Any one of these can have a failure, and if any of those things fail or don't go quite as expected, the whole function has to rerun if you're even catching that in the first place. There are a lot of solutions for this type of work, but there's kind of 2 directions you can go with it. There's the retry problem, which is how are you handling errors? What are you doing about them? But then there's the long-running problem, where some of these workflows are going to run for longer than the server that they're running on might even exist. Like, sure, there's actually a pretty good example in here with the sending of an email 7 days later, where you get the user, you send them a welcome email, then you wait 7 days, and then you send an email 1 week later as a check-in to make sure they're doing well. This type of code can be written on a traditional server. It can't be written on Vercel because on Vercel, you have a Lambda or whatever equivalent they're using at any given time with Fluid Compute that has a specific amount of time it's allowed to run, up to around 800 seconds, if I recall, which means you can't wait 7 days. But Theo, I'm using a real server. I can wait 7 days. What happens if you redeploy? Seriously, think about it for a second. If you have code that is running and it's waiting for 7 days before doing the next thing, and you deploy a new version of that code, are you just going to kill the old server? Are you going to let it keep running until everything else that's still on it finishes? What happens if the server has to restart? What if another process crashes it? What if a developer ships an update? What if the syntax for the function changes? What if any of these things happen? Your code that is sitting for 7 days waiting breaks. And that's why there's a whole industry of workflow providers that are ways to break up your code as a third-party service to handle these types of things. You can spin up a cron and pray a whole bunch, but you can also use other services. The best known one is temporal.io. I still cannot believe they raised such an insane amount of money. I still don't know many users of Temporal. I just know a lot of people who talk about it and think about it a lot. Again, send email, wait 30 days, then send another email. This type of code is something a lot of people want to be able to write because the alternative is letting the logic live outside of your code. If you think about things, here's a weird way to think about things. You have your code base, and within your code base, you have functions. Chances are you have a bunch of these in your code base. Who doesn't? Let's say this function calls some subfunctions that might fail. I'll make it yellow to indicate like this might not run properly. These ones always pass. These ones always run as expected. But what if one of them doesn't? How do you handle that within your code base? Traditionally, you've had to do some things that I don't necessarily love. Let me group these quick. The reality is that your code base is inside of something else. Your code base is inside of your infra. And if your code base swaps out because you just shipped a new version of it, but the context of what's going on lives inside of a single function inside of that code base, you're screwed. So what ends up happening is parts of this function get moved out of the code base into some other piece of infra, like a third-party provider like Temporal, in order to call the functions in your code base via API calls. So you end up with your infra, and then some other infra, like let's say you're using Temporal. And you put this function in here. This function has steps. And this function now has to call other things. So it will call this function maybe, get back a response. And this is all over HTTP now, by the way. Get a response. Maybe it doesn't. Maybe it has to call something else. But you've now pulled this code, this functionality, this behavior out of your code base and moved it externally. And chances are you also have to store what its current state is, which means it's not a variable in the code anymore. It's now an external value in a database that has to be pulled from. This takes something that should have been simple, like code that goes 1, 2, 3, 4, breaks it out into different infrastructure, and all of those layers are now things that you have to encode in your database, in multiple code bases in different places. It's now an infra orchestration problem. And for a lot of places, this is necessary. Services like Temporal do make this easier by giving you an SDK that lets you write code that's in your code base, and they manage the current state of things and try to keep things in flow in a relatively simple way. There's also other services like Ingest that does a really good job with this. This is the one that I've historically used and had a really good experience with overall. You define steps, and then you can call these steps from other steps and have different pieces throughout. You can call step.sleep if you want to take a break, these types of things. But you have to make sure that the code is up to date, or When you put a step.sleep in something and you have a value above, you need to make sure the value stays the same, which makes a lot of this stuff more complex. There's also trigger.dev, which is another one I really like. The founders of Trigger are awesome. I've had such a great experience hanging out with and chatting with these guys. And you'll see, again, a lot of similarities where we have tasks, which are kind of like steps. And we do things in here. We wait for completions. If there's no result, we throw an error. Image, we wait for that. If there's no result, we throw an error. Then we return it. You also have schedules where you can set up tasks. You can wait for things. So here they have the wait.for. You're getting the idea. A lot of these things are similar concepts of keeping your execution reliable and having workflows where different steps can happen. There are people arguing that what temporal does is different, and in a lot of ways it is, because it doesn't have some of these concepts, but it really wants to make sure every step in your code succeeds if it possibly can succeed. A lot of the branding for these will be create fail-proof apps, create reliable code. The goal here is to make it so code where there are lots of layers that have potential to have errors are less likely to not have the errors, but be blocked by those errors. If every function if you have a function like, let's say, we go back to the example here with the email send. Let's say that creating a user has a 0.5% fail rate. Sending the welcome email has a 1% fail rate. And then sending the 1 week check-in email also has a 1% failure rate. Those add up really quickly. That'd be 0.995 times 0.99 times 0.99. You're now down to 97.5% reliability on that. That means that 2 out of every 100 users are going to hit an error. But if each of these steps you're willing to retry 3 times, you take the 0.05 or 0.005. Yeah, you take the 0.005 to the power of 3. That's a much lower failure rate when you're willing to retry it 3 times. You could surely write code that does that, but that's just one of the layers. So the thing to really consider here is that there are errors that you want to retry from, and there are workflows and timelines and schedules that you want to run with. But none of these things really fit in your code. Ideally, your code is as simple as do this, then this, then this. But the reality is that the things we do are not that reliable, especially in this world where we're calling all these different tools, we're hitting all these different services, we're sending emails, we're interacting. Every one of these steps has a chance of failing. So we could write our code entirely different. We could call each of these functions with a wrapper that will do retries and handle errors. Sure. We could go all in on something like effect. Cool. But then what happens when we need to wait 7 days? The durability and the scheduling are 2 difficult problems, and the solution to both is to make your code way less readable and descriptive of what you actually want it to do. Ideally, code should be as simple as describing the intent of what you want. It should be as simple as the code is here. We should be able to just create a user, send them an email, wait 7 days, and then send another email. But due to the nature of how infrastructure works, of how code works, of how servers work, this has not been achievable. So what Vercel has done here is added directives and a ton of compiler hacks to make it possible. And I think the result's actually pretty cool. Vercel's not paying me for any of this. I had no idea this was happening ahead of time. I went in very skeptical. It's like, oh God, more directives. But the more I've thought about it, the more I've come around to this. Not because I think every single complex existing system or workflow could be moved to this and it'd be great, but I think more and more developers are starting to encounter the need for these types of things. I'm going to do my favorite thing. Make a spectrum out of something that is not actually a spectrum at all. This is the how important are your errors spectrum. You might recognize this because I've covered it before. On one side, there's meh, you don't really care. On the other side, if we error, people die. Like you're building medical tech or something like that. So on one side of this, you're probably not writing tests. You don't care too much about type safety. You're throwing any's all over the code base. Who cares? On the other side, every single line of code is vetted by 5 people. You have a crazy suite of tests. You're doing everything you can to make sure your code doesn't have any unexpected consequences and that the expected consequences are within your tolerance for errors. As you go up and down the spectrum, the things you're interested in, the tools you use, and the way you build will change a lot. Where on this side, you might be playing with vanilla JS. On the other side, you're probably playing with something like Rust. The reason you might recognize the spectrum is my previous video on never throw, effect, and also my crappy little wrapper for promises, my try catch wrapper that gives you the error and like null cases. So you have like const, results, error. You know, the classic stealing Golang syntax. So imagine you're building an app. And this is your app. This is the space in which you have to care. And your app is writing code that like hits a database once per API request. The database is more reliable than your actual code is, so it's probably fine. You don't care too much because it's generating images for people of their dogs or whatever. Who cares? But then you start using a third-party service that errors in a couple different ways. Now your endpoints are throwing random errors and you're getting frustrated with it. So you decide you want to handle this better. You could try out my try-catch wrapper. And maybe this is enough. Maybe the line for where this is good enough is here, and your code doesn't pass that line, so you don't care. So you're fine here. You're happy with the try-catch wrapper. It more than carries you. Maybe you have more, or maybe that's not enough, and you're seeing more and more things that are hitting errors. Maybe it's time to move to never throw, which is a great library. Never throw is an attempt at a somewhat minimal layer to add to your TypeScript, where you, instead of throwing an error, you return an error type, and you strictly make sure that you're doing this everywhere where an error can possibly happen. Let's find a promise. So here we have an imaginary database, and this imaginary database can have an insert function that might error. So we wrap this with a result async.from throwable for this, and then we return our own custom error here. I also noticed there's a typo here. There should be another parenthesis there. Response is type of user results, yada. Now this can be safer. No, this can be safer than using result async from promise with the result of a function call, because not all functions that return a promise are async, and thus they can throw errors synchronously rather than returning a rejected promise. Yeah, you see, JavaScript's not a great language. Yeah. Regardless, I've had a lot of fun with never throw. It tends to be my solution when I'm running into too much complexity in our error management, and I just want to like know where things are failing a bit more reliably. It's helped me clean up a lot of code and better understand why things are failing. But if that's not enough, like to be real, for T3 chat, it's not enough, because as much as people like to say T3 chat's just a light wrapper, oh man, I wish it was. The amount of random places things can go wrong at the level of throughput we're doing, like every way a service can fail, it will for us hundreds of times, which is why effect has been really good for us. Effect is effectively a whole new language on top of TypeScript, within TypeScript, that lets you write code in a very different way that requires you to rewire your brain a whole bunch, but it makes it way easier to manage the workflows that you're running, to manage the code that's executing, when it's executing, how values are propagated through that code, how you handle errors, how you handle concurrency, async, and so much more. It's a higher level rethinking of how you should write your applications on the server side especially. We use this for upload thing because we had so many layers of asynchronous bullshit that it made way easier to keep track of, that I love. It's also very functional programming build, which I also love. I know I'm going to become a big effect guy once I dive in a little deeper. I had just started before I had to have my hand surgery and just have been demotivated from using my computer throughout a lot of that time. So I haven't had the proper deep dive just yet, but I do plan to. The point of this is that at different points in your developer journey, the need for things like this becomes much clearer as you get to those points. If you're working on small side projects with a couple friends, you might look at effect and be like, what the fuck? Why would anyone ever want this? But if you're building really complex asynchronous workflows and you're used to languages that handle these things better, you might look at effect and be like, oh my God, why isn't everyone using this? Now that we've said that, I want to bring back another spectrum I've talked about a lot. This one's going to feel really out of place, so just listen to me for a second. This is the how complex of web tooling do you need? So if you're building a website and it's a static blog, your needs are very different from something like Figma, which is a really complex web application. So if you're on a static blog, you're fine just writing HTML. But if you're in Figma, you're probably deep in Canvas hell. I bring this up because there's different technologies that are beneficial on different sides of the spectrum. Something like React, I would argue, fits pretty well here, where if you're building a mostly static site, React's not going to benefit you at all. And if you're building something dynamic enough, React won't help you much there either. But stock vanilla just HTML is pretty limited in how far it can get you before you're miserable. The problem here is that there are lots of categories of sites where HTML isn't quite enough, but it sucks that you feel like you have to adopt React just to add something. So if you have a blog with a dynamic comment section, suddenly stock HTML isn't enough. You need to bring in some JavaScript, and you can go write all that JavaScript by hand yourself. And now you're going to deal with a lot of weird, annoying edge cases and things. Especially if you want to have an experience where you like hit post for your comment and the page doesn't have to refresh, it just shows up in the UI. Good luck doing that vanilla. You'll probably at least bring in something like jQuery. It'll make life easier. But man, this is when you're going to start reaching for a framework. But the reality is that you'll be right on the edge of where the framework becomes useful. And it kind of sucks that up until this point, it feels like HTML is enough. So why the hell am I talking about HTML and Figma when I'm supposed to be talking about durable workflows and execution? Because there's another framework I haven't got to talk about in a while that people don't realize how much I like. HTMX. The magic of HTMX is not that it can replace React in the majority of websites. The magic of HTMX is it meaningfully increases how far you can go before you have to adopt React. HTMX allows for these minimal but meaningful interactions on your websites, things like your comment section in your blog, things like your shopping cart on an e-commerce site, things like basic feed management in a Twitter clone where you post and it just appears in the feed. These types of things previously benefited greatly from bringing in a framework, even if you only had one or two things like that in your code base. And it sucks that 90% of what users are seeing can be done static via HTML, but then there's that small little like 10, 5, maybe even 1% left that makes you feel like you need to bring in the framework. And the result is you have a lot of people who end up resenting the framework because they don't want to use React. They feel like they have to use React because it solves one small specific problem that their framework or tool of choice isn't quite equipped for. And I think it's awesome that HTMX allows for devs that want to just do static HTML, that don't really want to build client-side JavaScript anything, to make a website that auto-updates on submit without having to go all in on building a JavaScript framework or bringing one in to build around. That's a good thing. This is why, despite me obviously being someone who leans in the React direction, I still really deeply appreciate HTMX because it has allowed for people to not need React when they just want to go a little further than their existing tools allow. You might see where I'm going with this. You could argue that there are two spectrums to the stuff that Vercel is cooking. There's the durability side, which is how much does this need to handle errors? This is what something like Effect would handle well. But then there is the longevity, scheduling, management, I would say. Don't really have a good word for this side. There are the two directions here, though, where one is about how well do you handle and recover from errors, and the other is how well do you handle scheduling as part of the tool that you're using. Something like Effect handles durability really well, and it can help some amount with scheduling, but once your server has to restart, it stops helping there. So like Effect would be here, where it's really durable, but doesn't necessarily help enough with scheduling. It's probably a little further, but then once the server dies, stops being helpful. So you have to ask yourself, where does your app go? Most apps are here, where the strength of most apps, I would argue, are in this general range, where they don't necessarily care about scheduling something a week from now or errors because they're just hitting their own database. It's unlikely that they are doing much that would require to better handling of errors or like context over time. But as your app gets more and more complex, as you hit more and more edges, you bring in more services, you have more errors, you're using LLMs for things more and more, you'll eventually hit a point where your shit's erroring way more than you want it to, and you have more problems that require scheduling than you expected. If you're just having errors, if you're just experiencing that as you go up this direction, it makes a lot of sense to bring in tools like Never Throw or Effect. But if you're also having problems with scheduling, like let's say you want to send an email a week after the user signs up, or you're using GPT-5 Pro, which can take 10 to 30 minutes to send a response, these types of things suck if your server might be replaced in the time the execution is happening. What I think is really cool about what Vercel has done here is they've effectively extended the safe range for just writing the code. If you were to not bring in any of the tools we've mentioned so far, if you were to just write code in vanilla JS and TS, I would argue anything past like this point, and you're going to start running into problems. If you need more durability, if you have things that are failing, it's probably time to bring in at least a wrapper for promises. And if you want to handle more complex scheduling tasks, you might need to bring in something like Trigger or something like Ingest. What's cool about what Vercel has done here is they've effectively extended how far you can go before you need tools like that. So if this box is vanilla JSTS, what Vercel has done with workflows is allowed you to not feel like you're leaving the tools or the systems that you're familiar with. So you don't have to learn a new syntax. You don't have to learn a new way of writing functions. You don't have to learn the quirks of when you call step dot whatever inside of a nested function that is sometimes being run on someone else's server, sometimes being run on yours. Instead, you're adding one string right underneath your function definition and meaningfully extending how durable your workflows are and how well you can handle these types of execution. This is why I am excited, because right now I'm running into problems with T3 chat that would benefit greatly from having the ability to wait an amount of time or re-execute with the current context when something happens. Seriously, this is going to make it so we can actually support GPT-5 Pro and other slow models, which I'm excited about because historically it's been really annoying to do with the way that we run code on Vercel. There are a lot of edges that make this kind of annoying, though, and it seems like Vercel has handled a significant number of them. One of the key pieces is the deterministic nature of these types of things. Let's say we want to time something. Let me... Content. Make sure I don't leak things. Okay, cool, we're good. Okay, I don't have any of the packages here. npm init. Cool, so I just made this fake copy of this. Let's say you want to keep track of when this started. So you have const started at equals new date. And then at the end, you want to have started at returned here. There's a big problem. Since we have this await sleep 7 days, it might seem like our code is just going line by line by line, and then it waits for 7 days, then the next thing runs. But reality is not so simple. You can't just sleep 7 days on a node that might not exist in 7 days. This code that we're running here, this instance that we're running, might not exist anymore by the time that step is completed. So what do? We recreate each of these calls to get to the next step. When the 7 days is done, we don't just immediately run this. We need to recreate the context on how we got here. But if we rerun this code 7 days later, the started at's now going to be wrong. It's going to be the time from that rerun. It's not going to be the time from the original run. These are the types of things that make it annoying to just do this and split up your functions. And the harsh reality is that the solution is often to go store a bunch of this stuff in database, keep partial states along the way, and have individual functions that get called on a cron or something along those lines when you do it by hand. Annoying as hell, to put it lightly. So what Vercel is doing here for you is every time you call an await on something that is defined as a use step. So here we have charge payment has use step. Now it's going to try and retry that step up to 3 times by default. If it succeeds, it will store the result in a cache that they manage for you, as well as any additional variables you hit and things like the new date call that happened here. They will cache what the result was, so when they have to rerun this function to resume where you were, they can get you exactly where it was before. This is far from the first time I've heard people having to patch date in order to do stuff like this. Everyone from Cloudflare has done this to prevent Spectre attacks to Convex to make transactions more accurate. Everyone that's doing weird things with the JavaScript runtime eventually has to patch date. It's almost a rite of passage once you're doing an interesting enough task with this godforsaken language. Yeah. The things you have to do to make your workflows and your runs and your functions deterministic, regardless of when they're being run or rerun, is difficult because the state could be different depending on when you rerun it. They had to handle a lot of things to fix it. The sandbox environments that workflows are run in already ensure determinism. For instance, map.random and date constructors are fixed in workflow runs, so you're safe to use them, and the framework ensures the values don't change across replays. You get the idea? Pretty cool. And again, the code is really simple. You're not really making your code more complex. This is something I strive for, and this is why I like stuff like React hooks. It lets you write the code how I would describe the thing to somebody. First, we create the user. Then we send them an email. Then we wait 7 days. Then we send them the check-in email. And in a world where you have AI agents that are calling dozens of different tools from various different services where any one of them could fail at any time, having a workflow that will more reliably retry those things along the way is a really good thing. If you have an AI agent that is doing 2 search calls and maybe writing something to a DB when it finds certain data, if any one of those steps can fail and then you have to rerun the whole thing, that sucks. But if you can store each of those steps along the way, or even cooler, if you can pass tools to an agent that are steps that can be retried along the way, it no longer matters that you deterministically describe these things as this is the 7 steps that always happen. The fact that a workflow can have a variable set of steps based on the conditions is really cool. I know Convex has workflows, guys. For what it is worth, another one of my favorite things, Convex, has workflows as well. And I've used these a bit for handling migrations for T3 chat. You can describe an action, which can be run as a step.run action. And you can even say to run this step after a certain amount of time. Really cool. I like this a lot in Convex. But the nature of Vercel's runtime is really, really powerful here. The combination of fluid compute, where you only build on active CPU time, alongside the deeper integration with full node support, it's so cool. And like, I have so many tasks where this will make my life meaningfully easier already. I'm excited. Like, this is one of those things that makes me more excited to build more complex things, because now I need way less complex tooling to do it. If I want to bring in 15 things, or if I want to bring in 15 API calls to random shit like FAL or EXA or all these services, it's way easier for me to make that reliable without introducing a bunch of complex tooling, changing the syntax, and making my code less readable. If I was to rewrite this with effect, there are like 7 people who would be like, oh yeah, that's way cleaner. And then the rest of us would be like, what the fuck is that? How am I supposed to understand this? As I said, if you get it, you get it. But if you don't, yeah. So what's the controversy? Why are people so upset about this? Is it because they're huge Convex fanboys? Is it because they hate Vercel? It's because a lot of people don't like directives. I'll start with Tanner's takes because I have a lot of respect for Tanner. I'll continue to die on the hill of magic directives are a bad API interface. They're not type safe, they're not extensible, there's no native runtime control, they're just strings. I can't believe I'm saying this, but I'd rather debate at directives. Please rewind history. Oh, also, I hate decorators. Just use first-class functions or higher-order functions or something composable. Merely trying to make a point that this is worse than even that. He also wrote a blog post about this. So I will read this, or chat, should I give my take on why I don't agree first, or should I read this first and not have to potentially renege? Read first. Okay, everybody said read first, so we will read first. A quiet trend in the JS ecosystem. For years, JS has had exactly one meaningful directive: use strict. It is standardized, enforced by runtimes, and it behaves the same in every environment. It represents a clear contract between the language, the engines, and developers. But now we're watching a new trend emerge. Frameworks are inventing their own top-level directives. Use client, use server, use cache, use workflow, and more are appearing across the ecosystem. They look like language features. They sit where real language features sit. They affect how code is interpreted, bundled, and executed. There's an important distinction, though. These are not standard JS features. Runtimes don't understand them, there is no governing specification, and each framework is free to define its own meaning, rules, and edge cases. This can feel ergonomic today, but it also increases confusion, complicates debugging, and imposes costs on tooling and portability, which are patterns we've seen before. We'll see how I feel as we go through. I really want to present his take as is and then give my counter after. When directives look like the platform, developers will treat them like the platform. A directive at the top of a file looks authoritative. It gives the impression of being a language-level truth, not a framework hint. That creates a perception problem. Developers assume that directives are an official thing. Ecosystems begin to treat them as a shared API surface. New learners struggle to distinguish JavaScript from framework magic. The boundaries between platform and vendor blur, and debuggability suffers, and tooling must special case all of these behaviors. We've already seen this confusion before. Many developers now believe use client and use server are just how modern JS works, unaware that they only exist inside specific build pipelines and server component semantics. I don't know if I agree with that. I might be in the bubble of like competent devs, but I've never seen anyone who thought use client and use server were things that just exist in the language. I think it's pretty well understood that those are React things. Is this me speaking from the bubble, or have you guys encountered people who thought that use client and use server were existing things, not just parts of React? Okay. A few people have also said that they've seen this. Use server was named wrong. I'll continue to be annoying about that. I would wonder, though, if instead of just use client and use server, they had done use React client and use React action. Would that have been enough for people to be quiet about this point? Because this feels like a small piece of the argument, that people believe that this is a native language feature. I've just never seen that argument before. Okay, chat saying that would have been better. I think for a majority of devs who don't keep up to date on things, they will start seeing the new directives and likely be confused by where the things came from. Yeah, use client is client to server boundary. Use server is the opposite. Yeah. I don't think use client created confusion. I think use server did, because it sounds like they're inversed, which they are on a deep fundamental level, but they're not on a top level, because use client is how you define a client component. So a lot of people assume use server is how you define a server component, but it's not. It's how you define a function on the server that the client can call. I don't think islands are the solution here at all. Islands only go one way. I'm not writing React every time I have things to do with the 5 seconds I save. I can go for another addition. I don't know what the fuck you're saying, Lube. Form sentences. They didn't call it use action because they have aspirations for it to do other things. So yeah, that one's a small point. Let's keep reading though. I don't know if debuggability is because of I don't know if the debuggability problems are because of the directives so much as the things the directives represent are inherently complex. I'm sorry, it's getting hot in here. And the fucking CO2 levels are bad already, goddamn. Credit where it's due. Use server and use client. Oh boy, is he going to agree with some pieces here? Some directives exist because multiple tools needed a single, simple coordination point. In practice, use server and use client are pragmatic shims that tell bundlers and runtimes where code is allowed to execute in a server component world. They've seen relatively broad support across bundlers precisely because the scope is narrow. Execution, location. That said, even these show the limits of directives once real-world needs appear. At scale, you often need parameters and policies that matter deeply to correctness and security. HTTP methods, headers, middleware, off-context tracing, caching behaviors, and more. Directives have no natural place to carry those options, which means they're frequently ignored, bolted on elsewhere, or re-encoded as new directive variants. I see a lot of these things as growing pains or one-time fixes. Like most of what you do through use server is going to use a post HTTP method. Middleware is functions that are commonly called in API endpoints. I think those being abstracted in a reliable way is better. Headers, you shouldn't be putting different headers on every request from the client side, ideally. Auth context is probably the most annoying one. I agree with that. Tracing is annoying whenever you go across a network boundary. Caching behaviors are annoying whenever you go across a network boundary. These are things that are always annoying. I don't agree that directives make them more annoying. I think directives let them not be annoying when they aren't problems, and they are just as annoying when they are problems. I think a lot about, like, is this tool making me write code that I can't rewrite another way? Is this locking me in because now I have to rewrite everything to fix it? Or is it locking me in because it's letting me not do those things yet, but eventually I have to write the same code I would have if I just never used the thing in the first place? It's a balance. So here's where directives start to strain, according to Tanner. The options in directive adjacent APIs. When a directive immediately or soon after creation needs options or spawns siblings, like use cache : remote, and helper calls, like cache life, that's often a signal that the feature wants to be an API, not a string at the top of a file. If you know you need a function anyway, just use a function for all of it. I'll admit I haven't looked too deeply in the new use cache stuff yet, because I've been really busy, and I'm more excited about the workflow stuff. And there's a good chance that the use cache stuff goes against how I like using directives. So here is what Tanner recommends instead of use cache. You have an explicit API, use cache from next cache. You wrap the function with cache. You have a strategy and a TTL bound there. I do like that more for caching. And for server behaviors where the details matter, import server from acme/runtime. Server is defined with a request response. And then you have the methods here as optional arguments. I see it for actions, but there's a problem. Like the magic of userver, and I fought about this with the guy who proposed userver, who wrote the whole spec for it, who implemented it, Sebastian Markbridge, because I had the exact same take Tanner had here. And he gave a really compelling counterexample. Imagine you have a row component, which has an item ID. And this row has content in it. Let me just, I don't want to do that. Just turn a mock table row with info about a fake item and a delete button. So let's pretend we have this fake component that's a row. Oh, is there a sound? I'm sorry, I need to just mute cursor forever. I hate that it makes sounds. I'm sorry, guys. I don't think it's whisper. I haven't hit any of the whisper buttons. I think it's just cursor making sounds, which I'll find a way to disable forever later. Anyways. Let's say you have this row let's say you have this row component that you're putting in a table in your database, or you're just rendering a bunch of items in a table. We've all had to do something like this before. Now you have a button for delete. You want to on-click delete this item from the server side. You want this on-click to delete this row. If I had a server function that was defined somewhere else, it's like const action equals server ID number, return item deleted, whatever, and then we call this action here. Like, this works, that's fine, but you can't use any of the data that exists here. If I wanted to use anything that was here, or I wanted to define this taking advantage of the context of when this was rendered and whatnot, I can't. It'd be really nice if I could define this in here, but I can't. And this is the thing that was shown to me by Sebastian that just broke my brain and made me realize the value of all this. If you were to define this as an async function, use server, delete from DB, item ID, now the context of what data existed when this component was rendered is within the scope of this action. Oh God, is it still beeping? What the fuck is making sounds on my computer? I'm so sorry, guys. Disable. Is there any way I can just make cursor never make a sound again? Me. Nothing there. Let me hear one of the clips. I'm so curious. I didn't change anything. My brain, it made me realize the value of all this. If you were to define this as an async. Okay, that does sound like whisper flow. I don't know why whisper would be so annoying. It's not whisper? Oh, is it because of the screen reader thing? Cool. Nope. Why? I just unchecked these all. I didn't hit OK after. Are you fucking me? If I could just disable the ability for my computer to make sound entirely, I honestly would. Okay, that fixed it all. Let me just re-record this whole fucking section. Cool. Love that for me. Ah. Okay. Third time's the charm. Fifth time, whatever. Let's say we have this row component. We've all had to render a table with data in it. There's a parent that has all of the data, and it's passing the item data and the item ID to each of these things. Now we want to make a delete button that works. How do we do this? Well, we can await fetch /API/items/item ID. Now this has to be async. Method delete. Get some not type safe data back. Hope it's good. Post a toast. Then go trigger the parent re-render and do all these other things. Fine. Annoying. But what if I want to have this function defined in a way that I can just call it? I can do what Tanner suggests and have const delete action equals server ID return, and instead await this. The harsh reality is that this is still compiler magic. If you have these in the same file, some compiler is hijacking this and putting different code in your bundle than is being written otherwise. So like the code I wrote here, sure, obviously like the JSX is going to be compiled in something else, whatever. But the fact that this whole function gets yoinked out and replaced with a fetch call is relatively unintuitive, because it's weird that a specific keyword that I import is going to change how this code gets compiled entirely. This isn't doing what a function does. Functions that wrap functions are called as part of your call stack. Functions named server, as Tanner is showcasing here, don't do that. They are compilers. You're replacing a magic string with a magic function. And the other thing here is that all context you need now has to be passed into this. So if I had const rendered at equals use memo new date, and I want to keep track of when this was rendered at when I do the deletion for some reason. There's a lot of other reasons you might do something like this inline. You might have other data that exists in this component that you want to use. I can manually pass all of these things over. But wouldn't it be nice if I could just define this function right here where I have to define a function anyways? That's what makes useServer cool, is it will include all of the context of everything that happened here. Console.log, this was rendered at. And instead of calling this delete action, you can do whatever you would have done there. So like db.delete item ID. Instead of response, it's now result, because this is actual server code. We don't care about what it returns to the client because we just want to revalidate. So we could even call like the revalidate path helper to revalidate the current content, or revalidate tag with whatever the database call was for that. This is what makes useServer cool, is it allows for functions that conceptually exist within a component to actually exist within the component and include the context of what is around the component. This isn't a security risk. People seem to think it is because they have fundamental misunderstandings of how it's implemented. The context of what is defined on the client side is included in the thing that goes to the server. Yeah, that's how client side works. This is a really cool behavior that if all the tooling and everything was being implemented correctly and people understood it, would be a much better way to define component-specific server-side behaviors within the component itself. Instead of the component calling an endpoint, the component defines a function that at comp time becomes an endpoint. I don't know why we like comp time stuff when we're in C and Zig, but we hate it in React and JavaScript, but it's effectively what's going on here. There is also a little hidden thing here that makes this not valid that no one's called out yet. You guys are calling me out for things that don't matter, but not the one that does. Since I have a use memo call here, this would have to be a use client component. And since this is now use client, I can't call use server in it. So I would have to define this in the parent and then pass it down, thereby destroying a lot of the potential benefit of this whole pattern. That's where the model actually falls apart. Not security, not directives, not the lack of wrappers. It falls apart because you can't compose use client and use server together for reasons that do make sense, because a file that runs on the server, because a file that only runs on server should not have client code in it. Yeah. If you're struggling to understand what my take is here, it's because I am too. There are benefits and negatives to all of this. It's not so simple as this is all bad. The idea of directives as ways to tell the compiler where this code runs is a lot nicer than having to spin up fucking Terraform and configure different code bases entirely for the different things. If you can define in your code what you want to have happen, and you want it to happen on a different place, either the user's device or a server or in a durable execution layer, and you can do that by adding one string, that's a good thing. A wrapper does not communicate that it's different. I don't think functions should be used to make code run somewhere else personally, because functions are used to run code. They have simple inputs and outputs. I like that we have something different we can use for when the code should be executed somewhere different. People are mad at me for bringing up the Terraform thing. I guess I have to elaborate more on that part. Yeah, you guys are all mad at me for that. That's fine. You're all wrong. Let me explain why you guys are all wrong. There are two problems here. One is syntax for code that runs somewhere else. Is one of the two problems. And then there's the actually running the code somewhere else part. there's a spectrum here. Is this a square? I think that I can do this one. Okay. Cool. It is very common that developers have a multiple computers problem where you have code that you want to have run in multiple places. Some code runs on your server, some code runs on your users' devices. Same code base, same syntax means that you want a solution that lets you write code the way you normally write code in the same code base that you're already writing the code in. So the place that you're writing the client-side code and the server-side code should have the same syntax, same style, same everything for client and server. This is how TanStack Start does it. You write code in a way where if you want a server-side function, you wrap your function with server. What Vercel is doing with directives is more same code base, different syntax, where they chose directives as the solution to communicate that these different things run in different places. Different code base, same syntax. This is using a TypeScript monorepo, stuff like TRPC and whatnot. And once you actually want to start deploying it, this is where Terraform and tools like that come in, because you need a way to define with different code that runs in different places and provisioning all of that instead of it all coming from the same code base. Now you need to handle the fact that you need to deploy code that clients receive on a CDN, and you also need to deploy code that the servers are running on a server. And if you, God forbid, have different types of servers throughout this, now you're running into the problems that hopefully the new workflow stuff will solve. Different code base, different syntax. Now we're in traditional REST land. So the reason that I'm bringing up stuff like Terraform is that that is how you handle things on this side of the world, where you have different code bases, or maybe you have like a monorepo, but different packages within the monorepo, one for the backend side, one for the client side. Tanner apparently updated the blog post. Exciting. Refresh that. Oh boy. Tanner's here, so hopefully he'll be able to correct any bad assumptions I have. But CJE's also here. I'm dealing with API design for a multiple computers problem right now. Not related to front end and back end, though. It's like different, like he works at Axiom, so like ingest servers, API servers, all of these things are complex. It's so hard to explain to even quite skilled developers. Even basic stuff like, it might be hard to talk to the same database from both places. Yeah, this is what's so hard. Everything from how you deploy to where you deploy to how you bundle to where you send code, this stuff is hard. And eventually you'll run into these problems. But ideally, the tools we use will get us further and further before you even notice you're having those problems. And that was the goal with use server and use client and server components, was how can React think about this relationship between servers and clients that gets you far enough that you might not end up needing to reach for Relay to have a good experience. Take your time, Tanner. So the point I'm trying to make is ignore all of this. We have all in the web dev world recognized that this level of splitting things up when you don't need to doesn't matter. What we care about now is when we're solving the multi-computer problem, do we want a different syntax for it, or do we want to use the existing syntax? Both of these solutions are using a compiler step to split the code up. So some code goes to the server, some code goes to the client, and some code goes to both. This is a matter of, should the thing that does that changes the way that the code that you're writing is actually running? Tanner copy pasting the wrong piece. No worries, man. Take your time. Should something that changes how the code runs and where the code runs just use function syntax? This is a debate that is worth having. Okay, considering APIs. This is a section Tanner just updated. They told me to take a look at now. Considering APIs instead of directives for option-rich features. Durable execution is a good example, like use workflow and use step. But the point in general. Directives can collapse behavior to a Boolean, while many features benefit from options and room to evolve. Compilers and transformers can support either surface. This is about choosing the right one for longevity and clarity. So here's one option, an explicit API with provenance and options. So we have a workflow wrapper here. We pass it our function, and we say this one can be retried 3 times and has a timeout of 1 minute. And then we have a step, fetch user, which has a cache of 60. I do like the syntax, but there's a reason that it's not ideal I'll get to in a second. Function forms can be just as AST and transform friendly as directives, and they carry provenance, which is imports in this case, and type safety. Yes, like this should solve all of the problems, but there are edges where it doesn't that make it much more complex on this side. You can also inject a global once, and now it just exists everywhere, which is cool, but I don't like magic variables that are defined globally, because you end up with the same problem where you'll end up with the same problem that we have here with beginner devs, where if they start working in a code base where these things are already done, they just think they can call the word workflow anywhere, and it's not that simple. If it's defined globally like this, the harsh reality is like most developers have never spun, or the average React dev has never started a React code base, which I hate. The average React devs never run create React app or create next app. They just started using the existing code base at their workplace that has thousands of things already defined in it. Okay, Tanner, I'm not saying that magic variables are worse than directives here. I'm saying that they have the same problem if you do a global definition like that. I'm not in favor of the global thing. I think we all agree. It seems like chat very much agrees, like doing this as a global definition, not something that we would recommend. So here is the thing that I actually think makes the directives part really cool. So here we have use step for calling an API, and if the response status is 500, we throw an error. Let's say that for different error cases, we want to change the type of, let's say that for different error cases, we want to change how many retries we do. We can do a top level number of retries like this, which I fucking hate. I hate defining values on a function like this so much. This is my least favorite syntax in JavaScript. When I learned you have to do this on page components in order to get data for it on the client side when you're trying to figure out what's going on in your component hierarchy, I hate this syntax so much. I hate doing this. A function's a function. Don't put values on it. That said, what I do really like here is when you call their helper error types, you can change how many retries occur. So here we're throwing a retriable error, and in this case, we are changing the retry behavior in a condition internally. I don't love the idea of defining these conditions externally, because in a lot of cases, we don't want to retry 3 times if we're hitting a too many tries error. In the case where we want to do a back off because we're hitting a rate limit, we want to have a different behavior than if we're hitting an error because of a random one-off thing. So I don't necessarily agree that it's a straight up benefit just having the wrapper be the place where you define these behaviors, because the behaviors can vary a lot internally. Twitch Tanner says, sure, throw a retry error, that's fine. Retries is an example of an option that would need to wrap or influence the compiler action. Scroll up more, okay. When you do this, you need a okay. Let's see. Here. Boundaries need to come from somewhere, which is why he prefers imports. If ecosystem's goal, make an ecosystem level import for everyone. When you do this, you create a standard. Standards need versioning, context, etc. Tell you when directives can do this, and you listen. Thinking on this. You almost never do this. I know you don't. Okay, yeah. Ball MQ solution. Okay, let me. Yeah, oops. Sorry, I want to read more chat. Bigger object is you starting to like export constant dynamic, force dynamic. Yeah, I hate all this too. Button macros. How do they do this again? Okay. I think I'm figuring out how to phrase like the points of disagreement on the user journey, because there's like every step along the way, one of these solutions is slightly better or worse. So the reason I like directives for the like very start, somebody who doesn't know what they're doing, that's just looking at the code base for the first time, is that like it makes it very clear that this is different from wrapping with a function. How do I put this? Like, if I'm going into a code base that uses use server and use workflow, and I don't know anything about JavaScript at all, it would stand out that these things are defined differently than functions. Whereas in something like TanStack start, the server function is another function, so to speak. So initially, I don't see those as different. But then, if I actually know JavaScript, but I don't know these frameworks, one of these is much clearer because it's a function. It's obviously going to affect the function. The other's like, what is that? A comment? Isn't this only a thing you use for use strict? What does that do? Is there a new feature in JavaScript I don't know about? So like step 0, I don't even know JavaScript. Directives make it clear that this is different from functions. Any amount more familiarity, and directives now feel like a feature that is confusing, whereas the functions less so. And as you go further down the line, the benefits and negatives of each occur. But I would argue that like biggest benefit that I'm arguing in favor of here is that different infra should, in my opinion, equal different syntax. That ideally, something that changes where and how the code runs should have a different syntax to indicate that. That's like very big and explicit and clear. I'd be okay with like the way macros work in Bun, where you have to import with for something like that. When you're going across boundaries, that could work for this. I'd have to see what it would look like in this type of context. But the other side here is that, and Tanner, please tell me if I'm not doing justice to your take here. And I want to describe this. Those are not configurable, I'll say initially. They're not configurable. They are not standard. They look like a language feature when they aren't, and you can just use functions. Is a fair way of putting the core level points. Oh, actually, more points in favor of Tanner and against this is out of code base composability is shit. So like if I have a package that I want to provide to you as a user that has the ability to include steps or server or use client, all those things, providing those in a package sucks because anything I use to try and bundle that and send it to you as a consumer on the other side is going to trim all that shit out. And chances are the bundler you're using for your code base doesn't even have the ability to introspect that and find it from packages anyways. So the composability, especially outside of your code base, is fucking garbage. Yeah. Tanner's argument needs to be traceable, need to have imports, NPM, GitHub, spec, version, all the above. As Gabriel says, also at Axiom, he's been writing more and more library code every day. This is becoming more and more important. Agree. I said I was going to piss everyone off with this video, and it seems like I'm doing a good job so far. I okay, actually, this comment I'm going to go in on. This is not an attack on you at all, plus Q, but I think this perfectly represents why I like directives. To me, it's unclear where directives are defined and come from versus importing a function from a package. Here is the harsh reality. You can't import infrastructure. You can't import someone else's computer. You can't import the server. You can't import a user. Those are things that aren't code in the traditional sense. Like, this isn't a debate of whether or not like a directive should just be a wrapper because a wrapper is the same thing and the directive is just wrapping the function. Like, directives are not directives are not decorators. They're not a way to change the functionality of a function. They are not adding a layer to the function in the sense they're not just like wrapping it with some stuff. The point of directives is that they are defining differences in where this code should execute, at least in the context of the things we're talking about. I don't know if I'm just thinking too much in like functional purity, but Wrapping a function in a function is hijacking the inputs and outputs, not hijacking the code itself. Waters down to, okay, where it runs is junior speak. It waters down where you sell and when you sell and market it, but that's not what's happening. Tanner, how do you feel about the syntax that Naman was sharing? This idea of a like addendum to your imports. Didn't see it. I'm trying to find it. Let me. Is there? No. Is there Naman 34? It was import API function from server file with on : server. So it's similar to the macro syntax here. Because like my holdup is very specifically that wrapping a function means something different than what I'm seeing directives used for. And I don't like the idea of function composition implying this. Yeah. The only problem I see with this is what was just said by Dev, which is that it forces you to move the function to a new file, which I don't love. Before use server, this was not taught or understood. I agree, but directives weren't used before either. I see this as useful as in it indicates that this is different from a function wrapper. It is hard for me to get over this idea of wrapping a function with another function can change where it executes and can like have this type of behavioral change for inside of the function. Like to go back to the example on the homepage here, the thing that doesn't click in my head that I could just, this could be the thing that I'm just wrong on, and I can accept that. That like when you put use workflow here, you've now fundamentally changed how this function runs. Every line, every call inside of this is going to behave differently because you put use workflow here. If instead you wrapped user sign up with like export function or export const full sign up workflow, and you wrap user sign up with workflow, it is much, oops, God, I can't type it all today. I don't like the idea that wrapping a function with another function changes how variables work inside of it. It changes how these lines behave. Is use workflow making it clear enough to a new dev or someone who's not familiar with the pattern that defining a variable now does something different than it does in a traditional function? Maybe not, but at least these two are co-located. It might be as simple as like, where do you define the fact that these calls behave different? That in this function calls work differently? I think that behavior should be inscribed within instead of externally. Because if we don't put use workflow here, it'd be possible to call user signup somewhere else without the workflow wrapper. Sure, you can be sure to like define it and always inline the function, things like that, kind of. But the idea of changing the way this executes, like I like to think of functions as magic boxes. You don't care about what goes on inside. if you wrap a function in another function and the external one changes how the individual lines run inside of the like inner function, that is the like, I don't want to cross this line for me. And I'm tolerant of something as gross and unconfigurable and not naturally composable as directives, when the alternative is a wrapper function that changes the behavior of the inner function. As was just said by Naman, in the end, these things are all compiler hacks anyways. It's all compiler magic, so they're all flawed. So the function is do anyways, though a higher order function can change how an inner function works. It can change the inputs that are passed to the inner function. And like, to be clear, I do love the way server functions work in TanStack. Like, I do love the fact that I can define a server function, give it a handler, and just call this anywhere. That's awesome. And the fact that you can do this without compromising on the composability or the configurability, where you can change if it's going to be a get or a post by changing in the create server function, like call these things, I do really like that. But this is defined inside versus outside. This solution requires that we break out all of these behaviors and make more small functions. The thing that I haven't seen before, because I've looked at all of these other solutions for doing more resilient workflows, and every single time you end up changing how you call things. Where we have to call .trigger, we have to define this as a task. Or if we go to ingest, where's the ingest example? I know I had it open. We have in ingest, we have our function that has an event name and then steps in it. So we call step.run for this first function, then we call step.run again for this next function. Is it that big of a change? Not necessarily, but it's not just the TypeScript that we would normally write otherwise. What I like about this, the reason that I'm into this syntax, is because it lets you write very boring idiomatic JavaScript and TypeScript and indicate that it will behave differently than normal with a thing. And personally, I think this level of compiler magic should be indicated with something novel, not with another function helper. I would also argue that what Tanner's doing is much less magical in the good sense. It's very explicit. My server time function is a server function that I define in a file and then import other places. I really like that. But when I just want to wait 7 days and send a follow-up email, Apparently there's more snippets in Tanner's post. Let me finish Tanner's post instead of fighting ghosts. Is it just this? Or are there more snippets that I missed? Oh, just these? Okay. Where were they? Here. It's just, we're changing how we define functions to work around this. And that is worth it when you're now committed enough to doing workflows to do that. But what's cool with the Vercel version is I can go switch to workflows on existing functions with like 2 to 3 changes that are just adding a string in random places. Like here we've, instead of send email just being a function that has multiple things in it, it's now a workflow wrapping an async function. And then the steps have to be another magic thing where I have to define it with a name separate from the variable name, and then the function there as well. Oh no, Ricky's posting more. I'm sure this isn't going to upset me. Yeah, I don't like how Ricky's talking about this either. It's one of those times where I don't like that I'm on the same side as Ricky because he's making it harder to make my argument and being a bit of a dick, and I'm trying not to be. It's like there is like everyone is correct here, and everyone's kind of wrong here, but mostly everyone is correct. Like everything Tanner said in this post is true. It's all a matter of like opinions and perspective on how far these problems can go. The lock-in argument is more valid here than in other places, I would argue. Because usually I argued like locked in, or usually I argue against lock-in as a thing because people just use this to talk shit when they don't necessarily understand like another thing. But that's not what's going on here. There is a real lock-in risk. Thankfully, what Vercel has done here is make an open source SDK and standard with nothing specifically tied to Vercel. The goal is to make it so you could put this anywhere. And they've documented it well enough. I do see a future where other places do this. I honestly would really like for some of the syntax to make it into convex. I think it would make a lot of the like definitions for workflows on the convex side much easier. And I'd love to play with that personally. If we want shared primitives, we should collaborate on the specs and APIs. They're absolutely real problems to solve. Server execution boundaries, streaming and async workflows, distributed runtime primitives, durable tasks, caching semantics. There's even more here too, like what happens to a durable task if the code underneath it changes out? Like what happens if I ship code that changes what a function expects and there's already a queued job for that function later on? Queue protection is one of those things that you don't realize you need until you really need it. And having that as part of like the built-in behaviors of the workflow stuff here is cool. But there's layers to all of this. And I personally think it's really cool when you can meaningfully increase the level of complexity your code base can cover without meaningfully increasing the complexity of the syntax. The problem here is that magic feeling of, oh, I can make something that is more reliable, more resilient with so little additional syntax, is that you're inherently foregoing a level of configurability, composability, and clarity with the people who are now writing code that way. And if you're in the weeds enough, you just stare at that like, oh my God, this is glossing over so much shit. It's making so many other important things impossible. Just use a wrapper function. And I can hear it and see it from both sides. And I don't know who is right here. All I know is that I like it. That it's a syntax that I vibe with. And I'm going to try it a bunch and see how I feel over time. I do want to run a poll. Vibes on directives. Mostly good. Mostly, all right. Okay-ish. Leaning bad. Mostly bad. I'm feeling I know how this is going to go. Remember my example here, though, before you vote. I like that use workflow exists inside the function where it's changing how each line runs. I don't like the idea of a wrapper function changing how the internal functions are executed. That I will stand on as my core argument of why I like this being inside, because it's changing how other things inside work. And ideally, a wrapper changes how the inputs and outputs of a function work, not how the inside of the function works. If you call a use step function in something that isn't use workflow, it behaves differently. Do you like the wrapper function style more if JS generators were used like an effect? So you did yield some task or something to make it more obvious the inside wasn't behaving normally? Yeah, I feel like effect is so abstracted that these things aren't as relevant. I'm also learning you could do use server, use workflow. Although what I would do is use server and then have a use workflow function defined that gets called. Okay, it seems like people here lean mostly bad, but it's not as crazy a split as I expected. The benefit of directives is the decreased flexibility, which makes it impossible to do stupid stuff. You have to define it inline in the function definition. How do you know on the outside when you call that this is going to take 7 days, not 7 microseconds? You've broken type inference completely by not having the workflow wrapper. That's a fair point. Like, if the workflow is being called lower level, like inside of like nested things, this does get messier. Oh God, this is how I know we've gone too far. You are comparing me to Brian Johnson. Yeah, I would argue that you don't care about the returns on use workflow, but if it's not a wrapper, yeah, the wrapper does benefit there. I don't like that I'm currently in a position to bend I do not like the fact that I'm currently in a position where I have to defend a thing from a company I don't like that I haven't used yet against a lot of people who I do like that also haven't used it yet. This is a very clean solution to problems I have right now that I like more than all of the alternatives I've seen proposed. And I will come back with a more concrete thought after I've used it a bunch. Yeah. I really don't like getting this deep, as Naman says, in what's almost purely a syntax debate. I like different syntax for different compiler behaviors. There are negatives to this specific syntax that was used. There are some benefits to the syntax that was used. In the end, us caring so much about these things is why the LLMs are going to win and just replace all of us, because we're too busy fighting about a magic string versus a magic wrapper. And I really hate that, because normally, like, I'm pretty strict where if somebody I consider smarter and deeper in the space than me, like a Tanner Lindsley or a Naman, if either of them disagree with me, I usually just side with them and shut up. And we're going at it over fucking syntax. Ugh. I'm just going to play with it. If you're curious, I recommend you do as well. Curious how you guys feel. Please be civil in the comments. I will be aggressive hiding people who are being annoying in the comments on this one, but if you actually are taking part in the discourse, which honestly, my chat's been pretty good about this overall, hopefully we'll have a productive discussion. I knew I should have built something with this before talking about it. I got nothing else. Please be kind in the comments. Until next time, peace, nerds. Oh shit, 20 gifts from Wabo. Thank you so much for the gift subs, man. I really appreciate it. Cheers, guys. Have fun. We will do our best. That was a grind. Thank you for the support, though. Really appreciate it. I feel like we scared Tanner away, and I feel bad. That's such a good one. I think Haskell is beautiful. I just have seen so, like, when I see people talking about it, it's not like how I use it at work. It's almost always like, look at how beautiful our language is. Thank you, Cyrus, for the sub. I have no idea why you were bringing up Ken Wheeler. Oh, shout out Ken Wheeler. Oh, God. What about Mistral now? Well, I talked about this earlier. Mistral arbitrarily restricts the quality of their models to their own service. LateChat uses a custom deployment of their models that you cannot use as a third party. So even if we added Mistral models to T3 chat, they'd perform worse than they do in LaChat. So I'm not going to do that because it makes us look like shit. This depends largely on like the workload of your background agents. Like, are they spending more time doing tasks, or are they spending more time waiting on LLM responses? How many things are running at a time? Is it just you? Are you deploying this to be user facing? Generally speaking, if you're building background agent systems that are spending a lot of time waiting for more data to come in from the LLMs, it's pretty hard to beat Cloudflare workers in the way that their compute works. But there are benefits and negatives to all the solutions. I don't think Fargate's right for very many of them. Sarah saying that they enjoy the new hairstyle. Appreciate that a ton. Thank you. Underswitch with the 1 month. Appreciate that. Wendro with the 100 bits. Use bits. Classic. Neutrino with use debit card. And the Jeff FX with 4 months of support. Thank you all. Oh, and NC Row Program threw a gift over as well. Appreciate that a ton. The signups actually a perfect example. Save DB step is a failure, which would have to respond with HTTP 500. But since it's part of the workflow, you can't make it a step inside of the workflow. It'll be called again. You're not going to call the workflow directly. You're either user signup plus post user signup workflow. I mean, I would assume that if the DB fails at that step, you would have the user signup be a step that throws an unrecoverable error and that gets hoisted up further. But yes, you do have to think about errors a lot. Wabo threw another 100 bits in. Thank you guys. So the thing about like running something like Claude Code on web is that you're not going to be blocked on like how much does the compute cost. You're going to be eating a lot more cost from LLMs anyways. So the compute platform doesn't matter as much in terms of cost. Where it does matter is in terms of like the functionality for cloning a Git instance, handling LSPs. And if you're doing all of that through just fucking bash on a real server, good luck. I really like Daytona for stuff like this. They're a sponsor, but if I was building my own equivalent of like a Claude Code cloud, I would almost certainly be doing it on Daytona because they have APIs for all that shit. Just stick with the basics. Don't adopt Effect until it solves problems that you have or that you're really interested in. Effect's really cool. But Effect is cool once you've had the problems it solves. It's not as cool if you just dive in and you're not like already a big FP nut. You know, HD negative with the 30 months of support. Appreciate that a ton. Yeah, Effect is absolutely overkill for a lot of projects. Yeah, once you're Effect pilled, it's really hard to get out of it. I've seen this happen to so many smart people I care about where they like weren't sure or they actively disliked it and then it hits them and now it's all they can do. Like I was talking to Julius, who's on our team for T3 chat, create T3 app, upload thing and all that. He was really unsure of Effect initially. And last night he was talking about how he's like even moving off of Zod in favor of the Effect schema. He's moving off of TRPC in favor of the Effect RPC layer. He just, once it hits you, it seems like it takes over. Wabo throwing even more bits. Don't feel like you gotta throw money my way, man. Appreciate it a ton, but not necessary. Sorry, YouTube chat. Next topic. I feel like it has to be this, right? Where server component's a mistake. Is Ricky still going off? Oh shit, Jason, I've not seen you in a while. Why is everybody here today of all days? Hope you're doing well, man. Everything's changed, yet nothing has changed. I honestly think you plus AI would be a very fun, dangerous combo, and I'm definitely excited to see how your dive into vibe coding has been. Yeah, RSCs were not a mistake, but their execution's been full of mistakes. This is roughly where I am at, too. This will be a fun one. Time to piss off even more people. Does my face cover the corner for that? It does. Okay, cool. We'll do that then. I still remember when server components first dropped. I was super skeptical. I said pretty out, or I want to reword this a little bit. I still remember the first preview of server components. I was super skeptical. You couldn't even call a wait in them. They had their own magic syntax for everything. You would have to name the files differently to indicate which components were server and which ones were client. I did not think I'd ever be a fan, especially when they made the changes I asked for and I saw the new magic use server and use client directives that made this behavior all possible. I was scared as hell. I really didn't think it would be for me. And as most of you probably know at this point, I was wrong and ended up really, really liking server components to the point where I was their main defender. Yet now, for most of the apps that I build and deploy to production, I don't find myself using server components very often. I try to use them for things like making a better shell for my apps, but stuff like T3 chat is basically not using them at all. I'm just shimming React Router in there, which is why I was kind of scared but also excited when I saw this blog post pop up. Are server components actually improving performance at all? Hypothetically, they should be. Server components should be the magic perfect solution where code that doesn't need to be dynamic doesn't get sent to the client at all. We just send them the HTML and deal with everything else on the server side. There's so much that should make server components an incredible experience both for developers and for users. But if the performance numbers aren't there, none of this matters in the end. And I try my hardest to be objective when there is data to point to. And historically, there hasn't been enough for me to really lean into. So I'm really excited to dive into what Nadia wrote here and discuss what the performance of server components actually looks like, and if this was all worth it or if we just went the wrong direction entirely. Need a good transition. Despite the fact that I really like server components, despite my love of server components, I'm not actually paid by either the React team or by Vercel, so we need a quick break for today's sponsor. This isn't going to be the video, I'm just answering a question. Ben asked why we're on Next instead of Vite plus React Router given the stack. It's the backend integration. It was way easier to deploy a server with a long-running LLM generation piece alongside the client-side stuff with Next.js. And I tried. I had multiple instances of T3 chat that were rebased on top of Vite, on top of Cloudflare plus Vite, on top of Remix V2. We even had a long-running branch with TanStack Start that Tanner personally contributed to, concluded that the SPA stuff wasn't there yet in TanStack Start, and then he went back and did a bunch of those things. Even just like managing where cookies come in throughout the pipeline and shit was obnoxious. So, yeah, someday we will be moved off. But for now, Next.js plus React Router has been surprisingly like usable. W for the bus driver for sure. Crowdfunding platform in a few days using your own DIY Bitcoin payment system. Try to make it a point to only use latest stuff that you were seeing. Start, convex, biome, switch over to Zed. Ooh, fun. Good shit. Let's get back to filming. I am so excited to have real data on this. I should have built something like this myself, but I'm busy, to say the least. Have you heard of server components? You probably have. It's everything anyone talks about in the React community in the last few years. It's also the most misunderstood concept. To be totally honest, I didn't get the point for a while either. It's way too conceptual for my practical mind. It is definitely pretty conceptual and high level considering the like weeds of inside of components that we normally live in. Even just the fact that server components have to start at the root makes it relatively unintuitive to grasp initially. We could fetch data on the server with Next.js and APIs like get server-side props way before server components were introduced. So what's the difference? Well, server-side props is like the single worst API ever defined. Like it's so funny to me. People are mad about the current APIs. It's like they never touched server-side props. It was the fucking worst in literally every single way. It's a downgrade in every measurable format for what we have now with server components. But yeah. We got to pretend that server-side props doesn't exist to have this conversation, because otherwise I'll just be angry, because I fucking hated that API so much. Oh God, I forgot about get server-side props. I have to use it daily at my Next 12 project. Yeah, fun fact, My blog originally started because I wanted to make fun of how much I hated the AirPod Maxes. But the reason I brought it back and started posting a little bit again before just going out on video was me wanting to bitch about how awful the type safety story was in Next.js 4 years ago now, which is kind of wild how fast the time has gone. But all of this was me bitching about the misery that was get server-side props. So here I had get server-side props as an example to get data to this component, but we don't know if user exists because we don't know what we're getting back in the component because it's a magic thing that gets passed down. You can manually type it, so I can define user as user from Prisma client, but what if I only select ID from user or select a different subset? There is no guarantee in passing the right data down because this is just two magic things defined in your page. You have your default page function, which is a component, and then you have the get server-side function, and there's no relationship between these. I will never for the life of me understand why this is the part that they copied in Remix, because this was bad here, it was worse in Remix. Anyways, but I do not want to just keep complaining about an API that hasn't made sense for 4 years. Yeah. Nadia here to quite the comparison. She compared how the patterns differ from both the implementation point of view, but also how data is fetched across the different rendering techniques and the performance impact of each of them in different variations, which apparently led to it all finally clicking for her. So hopefully, if you're not at that point where server components have clicked, our read through of this will get all of us there. This is exactly what the article does. It looks into how client-side rendering, server-side rendering, and server components are all implemented, how JS and data travel through the network for each of them, and the performance implications of migrating from client-side rendering to server components. Because these are all different. People seem to think that SSR and RSCs are the same thing, because they're 3 letters that have server in it that are for React. But RSC is just taking components that render on the client and also rendering them on server. Server components are components that only run on the server. Big difference. And I went to a semi-real multi-page app to measure all of this, so it'll be fun. It's available on GitHub in case you want to replicate the experiments yourself. I'm going to assume you've at least heard of initial load, client-side rendering, server-side rendering, the Chrome Performance tab, and how to read it. If you need a refresher, here are some articles. And again, article and author will always be linked in the description. Nadia killed it with this, so definitely give her a follow if you haven't yet. This is a very good post, and authors writing stuff this good deserve some attention. She also has a book on web performance fundamentals that seems really, really good. And judging by what I've seen so far, probably a worthwhile purchase. All this is linked in the description. Introducing the project to measure. It's an interactive and beautiful website. One of the pages looks like this, has an inbox. Some data on the page is dynamic and fetched via REST endpoints. Namely, items in the sidebar on the left are fetched via /API/sidebar, and the messages on the right are fetched via /API/messages. The sidebar endpoint's quite fast, taking 100 milliseconds to execute. The messages endpoint takes up to 1 second. Someone forgot to optimize the backend. Totally unrealistic. Full project's available on GitHub if you want to take a look. Face cut this to when I was plugging the author. CJE is one of the most trusted people in my community, says that the advanced React book Nadia did is also really good, and I take his word over mine. I'm sure it's great. That's my article. So let's define what we're measuring. When it comes to perf, there's 1,000,001 things that you can measure. It's impossible to say this website is good or bad perf without defining what exactly we mean by performance, good and bad. Oh God, I love this already. This is a very good article. For this particular experiment, I want to see the difference in loading performance between different rendering and data fetching techniques, including server components. For the purpose of understanding them all, and also answering the question, are server components worth it from a performance perspective? Going to use the Performance tab of DevTools for measurement with CPU at 6x slowdown and network slow 4G. You can use Chrome DevTools to arbitrarily slow down your browser, slow down your computer, and your network in particular. But 6x slowdown means a different thing on a different computer, so not always the best way. And the way that they slow down your CPU is not necessarily the best representation of a slow device. If you want to make sure your shit works on slow devices, buy a slow device and test it on it. It's the only way you can know. This all does help a ton, though. I do recommend at least doing these types of tests. She's going to be measuring the LCP, which is the longest contentful paint. How long does it take for the major content, like the core content, to render, even if it's just skeletons? The sidebar items visible, which is when do the things on the sidebar appear? The messages visible, which is when do the messages appear? And then when does the page become interactive? When can you actually click things and do things and expect them to work? These are shown as the LCP, where like the page skeleton exists, but the sidebar and the inbox haven't loaded yet. Then you have the sidebar loaded in, but the inbox still has to load. Then you have the inbox loaded in with the messages. Then the button for toggling light and dark mode becomes interactive because the JS is loaded and is now active. This is an important piece because when that happens, might even change throughout. Oh boy. This is a fun call out. Since in dev, everything's using HTTP 1 servers, the limit for how many things can run in parallel with HTTP 1 is 6. So you'll have things that would have otherwise been batched in prod get chunked out into different loads because you can only load so many things at once. She wanted to make sure she was copying how this would actually work in production with a real CDN. So she tested locally, So she tested locally by imitating CDN behaviors using Caddy as a reverse proxy. So let's start with the client-side rendering performance. CSR means that you load the whole script on client, and then the script goes and fetches the data. So here we have the script and the link. So this is where the CSS and JS come from. So you load the HTML, your browser goes and fetches these. Now they exist inside of the context of the browser. Now the JS can execute and do what needs to be done. And until then, you don't see anything. This transform this empty div into a beautiful page. The browser needs to download and execute the JS files. The files will contain everything that you would write as a React dev. So here you have your React components, you have the layout, sidebar, main content, and then something that will actually mount it to the root element. And until then, it's an empty page. React itself transforms the entry point app component into DOM nodes. Then it finds the empty div by its ID and injects accordingly. So if you look at the performance tab here, you have the HTML, the JavaScript, still an empty screen until the JS runs, then it paints, then it goes and does the fetch calls, and then it renders the rest of the data once it comes in. But notice here, the key is that the HTML loads, you see nothing. The JS loads, you still see nothing. The JS executes, now you see things. The HTML loading and the JS loading is not enough for you to see things. As she says, in real life, this will be much messier because you have multiple JS files, sometimes chained CSS files, and a bunch of other stuff happening in the main section. If you record the actual profile for the project, you'll see this. You have the index.js, the vendor.js, radix, editor, date functions, and the CSS all loading, thankfully in parallel, but all things that have to complete loading before you could start seeing any content. Data fetching for the sidebar messages is triggered in the JavaScript itself. You have a use effect where the messages are fetched and then stored. It could be any data fetching framework like Tanstack Query, for example. In this case, here we are, Tanstack Query. Nice to see. Doesn't really matter what's important here for the data fetching process to trigger. The JS first needs to be downloaded, compiled, and executed. So no data is being fetched at all until all of those things happen first. That's the key thing to understand with SPAs. You need the page to load, trigger the load for the JavaScript. You need the JavaScript to load, execute, then figure out what data it needs to fetch. And after all of that is done, you then finally start fetching data. Which is why when you don't have that JavaScript cached, it can take up to 4.1 seconds to get that first paint because it takes so much time on this fake slow device and slow connection to get all the JavaScript to do that. So you're waiting for 4.1 seconds to see anything on the screen. This is why people don't like client-side rendering. That is really bad. That's enough time for someone to think your website's broken. Aside from everything related to the nice dev experience and learning curve, which are huge deals by themselves, there are two main benefits to SPAs compared to more traditional websites. Because obviously this is bad. So like, why would we ever do this? Because of the dev experience, learning curves, and a few other things. First thing is performance. Transitions between pages when everything's on the client and there's no back and forth with the server can be incredibly fast. This is why we went single page app for T3 chat, because we wanted it to be as fast as possible when you click around. When I click other projects, I'm clicking now. As soon as I click, my other chats appear because I preload all of the data. And when you click, I'm just changing out what data is rendered in JavaScript. Nothing is loading when you navigate. Yeah, in her example, navigating between pages takes only 80 milliseconds. It's as close to instantaneous as it can get. The other important piece is that it's cheap, ridiculously cheap. You can implement a really complicated, highly interactive, rich experience, upload it to something like the Cloudflare CDN, have millions of monthly users, and still stay on the free plan. Perfect for hobby projects, student projects, and anything with a large potential audience where money is a significant factor. Depends on what the APIs being called are, to be fair. I still don't think the argument in cost is the real reason that server-side rendering matters. I have an article about this on my blog I never talk about. SSR isn't that expensive. It's really not. This started with me bitching on Twitter because I was so annoyed at people having this misconception, but SSR is not that expensive. If you game it to be a really slow render, it can be not free, but it's effectively free. It's so cheap. Yeah, with a SPA, there's no servers, no maintenance, no CPU or memory monitoring, no scalability issues. So what's not to love? I mean, if you need data from a server, you will still have these things. It's just that you're not also rendering React on that server. Yeah. And those 4-second load times aren't as bad as they look. It only happens the very first time a user visits, but it also happens whenever you push new code up. Granted, for your landing page, it's unacceptable, but for your software as a service project, where you expect users to visit the website often, 4 seconds will only happen once per deploy. Then the JS is downloaded and cached by the browser. Second and following loading numbers will be significantly reduced. Yeah, once the JS is cached, once the JS is in the browser cache, it's only 800 milliseconds for the LCP now. Final number I'm interested in today is when does the toggle become interactive? In this case, since everything shows up only when the JS is executed, it will match the LCP time. So as soon as you see the content, you can click the content. Important distinction. The same time the browser's showing you this UI, the UI is working because the code that shows the UI is the same code that does what the UI does. So now let's compare with server-side rendering. No data fetching. The fact that we have to stare at a blank page for so long started to annoy people, even if it was for the first time only. Plus, for SEO purposes, it wasn't the best solution. This is because you do SEO by putting things in the head tag that describe the page, and also occasionally content on the page that is being scraped by Google and whatnot. But if the content isn't there until you load JavaScript, execute this JavaScript, and fill the page, a scraper can't find that unless it's running a full virtual browser to execute the JavaScript and populate the page, which is so much work that most search engines don't bother, or they put less effort into the pages that require that. People started scratching their heads to come up with a solution to how slow SPAs were, while still staying within React ideally, because that's just too convenient. No one wants to give it up. We know the entire React app at the very end looks something like this. DOM elements, render to DOM app. But what if instead you rendered it to string, and then you have this HTML string that you can send down? Like the actual string that the server can then send to the browser instead of an empty div. So instead of one empty div that's root ID is app, yeah, now you just pass the right content down. So you can do very simple client-side rendering where you render the app to string, and then you send that down, and then the HTML has the JS tag so it can take over on the client right after. Just needs one additional step. Find and replace a string in the HTML variable. Inject it in the server response. HTML with SSR, you replace the root with this HTML string, and then you send it down. This is a basic functioning server rendering thing. Funny enough, I wrote very similar code when I was doing my benchmarking of Cloudflare recently. Now the entire UI is visible right at the beginning without waiting for any JS. And this is server-side rendering as well as static site generation, because render to string is an actual real API supported by React. It's the core implementation behind most of the SSR and SSG frameworks. And also my benchmark. A lot of people don't know this. There's an API in React where you can pass it a component, call render to string with a component, and it will respond with the HTML for what it would have rendered. If you do this for her existing client rendered project, it will become a server-side rendered project. The performance will shift slightly. The LCP number will move to the left right after the HTML and CSS are downloaded, since the entire HTML is sent in the initial server response, and everything's visible right away. So this is the key. HTML gets sent down. It won't look quite right because the CSS hasn't loaded yet, but you don't have to wait for all the JS to load. You just have to wait for the CSS to load. And if you want, you can inline the CSS in the HTML. You can even bundle it in via some fun plugins for Next.js. And now, once the whole HTML is loaded, everything is visible. Nothing works yet, but it's all visible. So first, you'll see that the LCP number where the page skeleton is visible should be drastically improved. But you'll still need to download, compile, and execute the same JS in exactly the same way because the page is supposed to be interactive. So again, you have to load all the same JS. You're just getting a better HTML. The only difference between SSR and CSR, if you just turn on SSR for a project, is whatever the initial state the JS would render is sent down by default. So the HTML is sent down with the empty LCP state, and then the JS has to spin up, do all of the same work it would have otherwise, and then all the content comes in. So you're just moving the LCP down. You're not going to change anything else. Yep. And while you're waiting for all of that, the page is visible. The gap between the page being visible and waiting for the JS to load to be interactive is the time where the page will appear broken. Most frameworks will now cache events. Like if you click a thing, but the JS isn't loaded, there's like a really small inline bit of JS that will cache the things you did. And once the JS is loaded, we'll replay those events. So usually you won't even feel this. That said, there are other frameworks that are built around their hatred of this desynchronization state where there's UI you could see but can't use yet. This was Quick's whole thing, if you're familiar with Quick. If you're not, no need to familiarize yourself at this point. This is why the time to interactive is so interesting, because during this time, the toggle in the header won't work. If you implement server-side rendering this way, where you're not building a queue system or using a framework that has this working already, that broken window is going to suck because those are clicks that effectively disappear because there's nothing there to keep them. But most modern frameworks have solved this problem. And also, only the LCP mark has moved because the JS still has to load, execute, and then start fetching. The data fetching doesn't happen any sooner with this pattern. So the server-side rendered version has successfully knocked down the time for like a page that's visible by like over 2x. But every other number is effectively exactly the same. So what if we do some server-side data fetching too? Because remember, the data is not being loaded. That happens after. If we want to do the data fetching on the server, we can. So here we fetch the sidebar promise data, we get the message promise data, and then we pass those down and render the app with that data already loaded, so we don't have to call React Query anymore. And we rendered a string, we pass the messages and the sidebar content that we loaded here. Again, she's not using a framework like Next. She's doing this as just serve functions that you could put in Express, which is really cool because it's showing like the concepts deeper. So we have a layout, sidebar, main content all being passed from here. But we also need hydration to work. So we need these components to have the data when the JavaScript loads on the client too. So the solution there is either you make them refetch it, or the easiest thing is you pass it as window data inlined in the HTML. And then on client side, you check is window defined. If it isn't, you use what app was passed. And if it is, then you use the value on the window that we assigned. This seems like a hack. And I hate that I talk about get server-side props again, but that's how it worked. We're just binding weird globals to the window. It's not as hacky as it seems, or it is, but it's how we all did it. And now the page structure changes again. We have the HTML, the JS loads, then the JS runs, and the page is interactive. But when the page loads, all the content's already there. But that adds new problems. So here we see it takes 2.1 seconds for the page to get LCP, but you have the sidebar and messages all already working by the time that hits. So you have the full page content ready to go almost immediately, but it actually takes longer for the content to be interactive because in the time you're waiting for that data to fetch, you have no HTML. If the server is doing those data fetches, the ones that are here, effectively we've taken these two fetch calls and put them before the HTML loads. So the HTML hasn't finished loading yet, so there's no way for the browser to start fetching the JavaScript yet. So you're now blocking the JavaScript on the API calls, which means that the time till you can interact has gotten worse. And you're staring at a blank page for longer because you're waiting for all of that to come in before you see anything. The benefit of this is that there's no loading states. You just go from browser blank page load to content already there. But this comes at the cost of now you are delaying how long till users can click because you pushed these API calls ahead of the HTML. The LCP degraded compared to the previous solution because we're blocking the response on the data fetches. So how does the Next.js pages implementation work? So this is the old school get server-side props solution. Get server-side props, we fetch this data, we return it. It's doing basically the exact same thing she did, so it shouldn't be that different. Yeah, client-side data fetching is pretty much the same as the server-side rendering DIY solution she did. Less time to interactive, because I'm sure that Next is doing some better things for that. And the server-side data fetching still makes the time to LCP worse, but everything else stays pretty flat from there. The interaction time is 3.5 seconds, which is still better than the non-Next solutions. Like, when people say use a framework, this is what they mean. You can bitch all you want about Next performance, but in a real world-ish scenario, it's still performing significantly better than the vanilla solution. So if you look at my benchmark where I compare the raw throughput for SSR on Next.js versus vanilla React, it makes Next.js look like a terrible choice. But when you're looking at how this impacts actual client-side behaviors, you'll see why Next.js exists. It's doing a lot of other things to make the performance better for users. Yeah, the LCP is slightly worse for the custom implementation. Sidebar messages, on the other hand, show up a second earlier in this case. It's a very visible use case of what will happen when code splitting is performed differently. Next splits the JS into many more chunks than the custom solutions, so they can all load in parallel, which helps a lot with fetching multiple things at once. But those parallel files steal some of the bandwidth from the CSS, so the CSS download takes longer than it would have otherwise. Interesting point. But having them all in parallel makes it faster down the JS overall, which helps with the reactivity gap, or the interactivity gap. Makes sense. And now, for the reason we're all here, server components. Very curious to see how this part does. Because ideally, it should be the best of both, where you have an HTML file that has enough data in it to do an LCP and start fetching the JavaScript, while also in parallel fetching the data from the APIs. The biggest issue with SSR is the no interactivity gap, when the page is already visible, but the JS is still downloading and initializing. That's not the biggest issue. The biggest issue with SSR is that you can't be doing things in parallel. You're effectively choosing between three options. I guess I need a diagram now. Okay. So there's three things that we have to do. We have to send HTML to client. We have to load JS, and we have to fetch data. In CSR and SSR, these things all block each other. We're effectively changing the order things happen. With client-side rendering, you first send HTML that is empty to the client. So it has nothing but the head tags to fetch JavaScript. You might have a hard-coded skeleton, but for the sake of a basic CSR, we're sending an empty div and a bunch of links to data to go fetch. Then we load the JS that is indicated in that HTML in the header, or in the head tag, not the header, same difference. Then once the JS loads, the JS has to be parsed and run. And then finally we can start fetching data. And the key is that you don't see the UI until here. You don't see anything until this point. So you're just looking at an empty page until then, or a skeleton if you hardcode one, but you don't. You're not looking at anything until then. And each of these has to happen 1, then 2, then 3, then 4. They all block each other. With server-side rendering without data, so we're not data fetching on the server side, we first generate or serve a cached version of the HTML. So the HTML with skeleton is sent. Ideally, you're getting this from a cache, but you might not be. So we'll assume, whatever, we'll just assume it's coming from a cache. Now you can see the content, but everything else is still the same from there. You have to load the JS, parse the JS, then start fetching data. What we've done here is change when you start to see the page looking how you expect, but everything is still blocking. Server-side rendering with data is where things start to get more different, though. So server fetches data to HTML sent to client. Now you can see, but considering the fact that the data fetch is the thing that takes multiple seconds, now you're not seeing anything until that's done. So it's actually the longest time till you see anything, but then there's no loading state. You see everything immediately. But it's not interactive yet. The JS still has to load. And then parse JS and make page interactive. So now you see better content. So I also want to make this a full line because you're seeing the full content. You just can't interact yet. The problem here is that you can't do these things in parallel. In an ideal world, you'd be able to fetch the data at the same time you're sending HTML to the user, and then they're loading JS while you're still fetching the data. I don't want this to be 1, 2, 3, 4 anymore. Like if we make this blocks, we have HTML, we have load JS, we have run JS, a bit smaller. And then we have the data fetch, which is the longest part. So all we've been doing this whole time is changing the order that things happen. In the standard SSR, we are just improving the quality of the HTML that comes down. Maybe we increase how long it takes for the HTML to come down, but you're just getting better HTML. That's all CSR versus SSR is by default. SSR with data fetching is reordering things a bit. So CSR, SSR, then SSR with data. The difference here is that fetch data gets moved up. So now you get a complete page sooner in terms of what it looks like, but you're not meaningfully decreasing the amount of time it takes for everything to happen. We're just shifting around what is where. If RSCs are what they're promising, what it should be doing is this. So let's see how the results come out. Introducing RSCs. To recap previous sections, fetching and pre-rendering on the server can be really good for the initial load performance numbers, but there are issues. She cites the no interactivity thing here. That's why I just broke off. Because that's a problem, but in my opinion, the problem is that we're not parallelizing anything. Oh, look, the second issue is data fetching. I want to prefetch messages on the server, thus reducing the time to wait for the messages to appear. It will negatively affect the initial load and the time where the sidebar items show up. Because what's happening here is, since we are waiting to load the JS until the data is fetched on the server, it takes longer until you can click because we're not loading the JS as early as we were before. So this ends up making it take longer till the page is interactive, which sucks. We wait for the data first, then we pass the data to render to string, then we send the results to the client. What if our server could be smarter? Those fetch requests are promises. They're async functions. We don't need to wait for them to start doing something. What if we could trigger those fetches, start rendering React stuff immediately, send down something to client? When the sidebar promise is resolved and the data is available, render the sidebar portion, inject it into the server page, and then send that to the client, and do the same for messages. We're replicating the exact same structure of data fetching that we had in client-side rendering before, but on the server. In theory, if this is possible, it could be crazy fast. We'd be able to serve the initial rendered page with placeholders at the speed of the simplest SSR and still be able to see the sidebar and message items way before any of the JS is downloaded and executed. Sounds promising. So to do this, we have to understand server components. Typical React component quite often just lays out HTML tags on a page, like the sidebar component here. There's a bunch of divs and links. It's all still JS. Exactly, this code is included in all the JS files that contribute to the no interactivity gap. But there's no interactivity here. It's just the HTML. Like, we don't need to send this as JS. We can send a less JavaScript, ideally, if it's something that doesn't change. A good example of this is like a terms of service or a like terms and conditions page, because those are just a bunch of text. You don't have to be able to click the div. So you don't need to send that as JS. The only reason this code is included in the JS bundle is because React needs it to construct the virtual DOM, because React needs to know where everything is on the page to change anything on it. But ideally, we don't have to send this as JS. In the current SSR implementation, whether it's next page or her custom hacky solution, the process of extracting the tree for the React components happens twice. The first time when you do the pre-render on the server, and the second time from scratch on the client side. Because when you do server-side rendering, the client and the server both have to run the same JavaScript code and come to the same HTML so it can all link together and provide you the experience you expect. And that's hydration, if you're curious. What if we preserve the tree regenerated on the server and just send it to the client, so React doesn't need to recreate the whole thing and just recreates the parts that are client-side? We could send less JS, reducing the size of the bundle. We wouldn't have to iteratively call all of those things in order to create the whole tree. So how do we send this data? You hack it into the window. And this is actually what happens in most RSC implementations. She migrated to app router, and sure as hell, this is what she saw. __next_f.push all of the data for this tree. It's a modified but recognizable tree of objects that represents what should be rendered on the page. This also does mean you're sending the data twice. You're sending it as HTML, and you're sending it in this embedded JavaScript tag. And when people say that server components don't need a server, this is what they mean. You can, at build time, generate the HTML that isn't going to be dynamic and have a bunch of different HTML pages that have this embedded in the script tag in the page, so you don't have to load JavaScript that isn't used. You can have JavaScript in a React project that is client only, that at build time generates different HTML for different routes, and then just never has to run on a server. It's just not running those components. Part of why I think the server component name is bad, part of why the rollout was bad. Server components should be really good. There are a lot of reasons they're not. This concept, people not getting it is part of it. With a server component, all that you're sending to the client is the HTML and that weird structure that we just showed. One of the advertised benefits you'll see that go together with server components is a reduction in bundle size. In theory, if all the code and library stay on the server and only the final structure sent to the client, the amount of JS downloaded should noticeably decrease. We know the impact of too much JS. This sounds like a good idea. Let's see how it works out. There's also async components. One of the cool parts of server components. You can have a component that fetches data, and you can suspend above, which enables streaming. In a normal SSR implementation, the server will generate the entirety of the HTML and then send it all at once when it's ready. But with streaming, you can first create a node stream and send the pipeable stream data down, so it sends it chunk by chunk as it's ready. What it does is it sends the majority of the page, and then as you finish, it appends new elements to the end with script tags that move them to the right place. It's actually really cool how it works. You don't need to know the details. What you need to know is your components effectively can pop in when they're ready from the same server call. The chunk boundaries for this process are not React components or async components, by the way. It's components that are wrapped in suspense. Remember this, it's crucial. We'll see significant changes when we start measuring. The working implementation of this for a multi-page app like her is insane. Docs don't cover it well. So it's an embarrassing number of hours trying to make it work, and the end result would have been I spent an embarrassing number of hours trying to make it work, and the end result would have been multiple really complicated files and still half broken. It's not a simple render to string like it was with the normal SSR. Yeah, doing this DIY and not doing it via a framework sucks, because that interop between the server and client is non-trivial, and some of the hacks that have been discovered to make it possible are, there's a reason that there's only 2 server component frameworks that are viable. It's not easy to implement, but when you use App Router, it gets a lot easier. And as she says here, Next.js App Router is basically a synonym for server components and streaming at the moment. Yeah, I wish this wasn't the case. I really do. But it is. It's really hard to use it. Server components now are experimentally supported in React Router, which is cool, but Next is still how you're using it almost always. So let's measure App Router after the lift and shift migration. She points out the fact that Next.js has a ton of other things like optimizations, caching assumptions, transformations that will make this not a viable test. So if she just rewrites over, it won't be a fair comparison because there's no way to distinguish between Next.js benefits versus server component benefits. But if she migrates to Pages first, then it's possible to compare between the Pages version that is doing server-side rendering and the App Router version that's doing RSC stuff. She already has the existing version with Pages and client-side data fetching. This is the app with the smallest LCP so far, the second row in the table. Migrate that to the new framework with a completely new mental model, completely new way to fetch data. Let's see. Lift and shift as much as possible. Make sure the app works and nothing is broken. In the context of this experiment, it means re-implementing routing a bit and using use client in every entry file. This will force App Router into client components everywhere. So isolate the effects of the new framework. Every benefit or degradation here will be because of the framework, not because of server components or streaming. So this is without server components, just moving everything over to App Router. She saw a meaningful improvement from the Pages implementation, 1.76 seconds to 1.28 seconds. Although it looks like the sidebar took longer to load from 3.7 to 4.4, 4.2 to 4.9 for the main content. Interesting that LCP got much better, everything else got worse. Yeah, 500 milliseconds better for LCP, 700 milliseconds worse everywhere else. Very interesting. Apparently, App Router delays all JS until after CSS is loaded. The Pages version didn't do that and would load them in parallel. As a result, the JavaScript loading stole a bit of bandwidth, and the CSS was loading slower in Pages, thus delaying the LCP. That's actually a really cool detail I did not know. I get why they would do it in order to keep like weird edge cases with layout shift from happening. That's very interesting. Also, App Router is very busy on the main thread, at least 100 milliseconds worth of tasks more than Pages was, because App Router does a lot more stuff on the client side. Yeah. In total, the effect I'd say is a bit meh. Maybe further refactoring would make it better. Not much you could do on her side other than maybe inlining the CSS because she's using Tailwind anyways. There's a flag for that, which would keep the CSS from blocking, which could help here. Yeah, even CJE didn't know this. That's how you know we're deep. It's really nice to see people who don't necessarily know all of the history of why all of these things happened on the React and Next teams, but do know how to profile things really well, because she's finding things I wouldn't have, because I'm too in the weeds of how these things were all implemented to think about this level of it. There's an XKCD on this. Yeah, the average familiarity. Silicate chemistry is second nature to us geochemists, so it's easy to forget average people probably only know the formula for olivine and 1 or 2 feldspars. And quartz, of course. Yeah. I don't know what people don't know in this world. So I'm too deep. But it's nice seeing that, like, because she doesn't know about the inline the CSS feature in this, she's finding things I wouldn't have found. But now we can compare with the server component implementation when we start removing the use clients in certain places. The JS was reduced all right. On some pages, it was just a little bit, so homepage only took a 2%, but others, by a lot. Login page went to almost 0 from kilobyte values to bytes. But most of the shared chunks didn't change at all, and the performance impact on all the metrics that are important to her on the inbox page were exactly 0. So server components by themselves, without rewritten data fetching in my app, didn't have any performance impact. And I suspect in most real-world messy apps, where use client is slapped randomly here and there without much overthinking, and eventually bubbling up to the very root of most pages, it'll be the same. Yeah, probably. Yeah, I think that's fair. But what happens once you change the data fetching a bit? Instead of use affecting the data on client, you have an async sidebar component that waits for data, parses it, and then renders accordingly. The complicated part here is that when you do this, the sidebar component can't have a parent that's a client component that mounts it. Like, sidebar can't be called from a client component. The root has to be server components, and then up to where this is rendered, it has to be. If you have client components between, you can render them, but you have to pass sidebar as a prop to those, or as a child to those other things. Once you did it, let's see the results. Oof. 1.78 seconds for LCP. That's a little scary that it got worse for that. It shouldn't, theoretically. But it stays at 1.78 for showing all of the content here. Did she not do suspense for this one? Ah, she didn't. Yep, called it. So what happened here is she's fetching the data and it blocks the page load, so nothing gets to client until the data is fetched. But you can wrap components with suspense and show a loading state. This is the one I care about. Woof, there we go. 1.28 seconds for LCP, 1.28 seconds for the sidebar, because the sidebar loads fast enough it gets streamed in almost immediately. Wait, why is messages 1.28 as well? That should not have happened. I'm not sure about her LCP measurement here. I might have to run this myself. Interesting. Yeah. It's so fast that all the numbers merge together again. Something somewhere does some form of batching, I'd assume, and those three ended up in the same chunk. Yeah. But what she did is she increased the load time to be 3 seconds for the sidebar and 5 seconds for messages, so that it will increase how long the whole thing takes, which makes the benefits much more visible here, where you could see we got to start loading the CSS and then the JS way earlier, but the HTML keeps loading because it's still sending data when it's ready. But with traditional SSR, you have to wait for the page to load, then all this stuff happens, but the HTML is not sending anything more. So what's the TLDR here? Client-side rendering is the worst for initial load point of view, as expected, but once the page is interactive as soon as it appears, and transitions between pages are fast. Server-side rendering can vastly improve load numbers, but it comes at the cost of the no interactivity gap, and also skeletons like become a harder problem to solve there. You're stuck waiting on browser load states much more so. I think client-side with skeleton is more ideal than traditional SSR in most cases. Fetching data on the server will slow the initial load, but will also make full page experience visible much earlier. Priority from traditional SSR to server components with streaming, namely from pages router to app router, can make performance worse if you're not careful. You need to rewrite data fetching to be from the server, and don't forget suspense boundaries to see any improvements. This is a significant dev effort, and it could require re-architecture of your entire app. Migrating from pages to app router can make no interactivity gaps worse because of the delayed JS download, but that might be browser dependent, and also you can preload the CSS. Server components alone don't improve performance if the app's a mix of client and server components. They don't reduce bundle size enough to have any measurable performance impact. Streaming and suspense are what matter. The main performance benefit come from completely rewriting data fetching to be server components first. Yep. Like, realistically speaking, if you're happy with the way your routing is working and you don't have any interest or plans to move data fetching to server, you probably shouldn't make the move yet. Where server components get really cool is when you are putting some effort into thinking through what components are server, what components are client, and what ones will be streamed in when they're ready. Chat's been calling out that she didn't mention partial pre-rendering at all. The way that she was testing PPR doesn't really matter. What partial pre-rendering is when you generate the HTML here during this step on server, PPR is caching that result and putting it on a CDN so that you don't have to wait for a server to send the response. But since she's doing a fake local reverse proxy anyways, that's going to respond almost immediately. The benefit of taking that chunk and putting it on a CDN is near zero. So not having partial pre-rendering here doesn't matter for the way she's benchmarking. So I don't know why everybody's saying that. Meh. Next 16 also preloads the cached bit, which removes the network hop cost. I'm not sure. Oh, so like on the server side, it skips steps because it has that cached part of the tree. Not sure I follow. On the client, like, oh yeah, this is for navigation. So I don't think any of these measurements were navigation though. So the thing that Naman just said, which is actually a really cool benefit, since partial pre-rendering is taking whatever the like generic static output is before everything else comes in. Basically, partial pre-rendering, it renders until the first await or the first time you call something that's user specific, like you check their headers or whatnot. So it goes down your React tree until you hit an await, and then it caches everything until then, throws it in a CDN, and now you can load that without the server having to load. But more importantly, you can prefetch that for all of the links that are currently available on the page. So when you click one, it can have that partial pre-render, that piece, ready to go when you click. So you see that immediately, and then the rest of the data starts streaming once the server spins up, connects, and sends you that data, which is cool, but that's not what was being tested here. It is a really cool benefit, and it gives you that same feeling that was being described earlier with client side, where when you click something, it changes immediately. What are you saying, Wendro? Next day's pages router with client-side fetching is the best performance overall. No, it doesn't. Looking at the same numbers. Pages router with client data fetching does not have the best numbers. Takes 4.2 seconds before you see messages. Also, do you see how short these times get once things are cached? It gets fucking free with app router, with server side stuff. It has the best time to interactive with data fetching without caching if you ignore the fact that a bunch of the content is still missing. But it has worse time to interactive as soon as you consider that JS might be cached and that you're interacting with content that has to appear still. There is no world in which, when implemented correctly, pages router is better than app router. It just isn't. So I'm like, could you click the toggle really, really quickly, like milliseconds faster when you're still waiting for content that would have been loaded in the app router version? Maybe. But that is purely because of the way the CSS is loading in. Like, that's not a real problem. You lose bandwidth for fetching the unneeded pages though, right? Yes, but like almost none, and it doesn't do that until everything else is loaded, which is fine. I think it's great that modern frameworks will prefetch things so that when you click them, it feels faster. No one is getting billed because they loaded another 500 kilobytes of HTML that makes navigating feel better. I think that's fine, as long as it's not blocking other data fetches from happening that are more important. Overall, this is really, really good, though. Thank you again to Nadia for writing this. This is a fantastic write-up. One of the best, like, first principles, making sure you understand the concepts and you're testing the right things and doing the due diligence to test the actual pieces that matter throughout it. I've never seen someone do this deep of a breakdown of these different methods and what the performance actually looks like, while also educating the reader as to how these things differ. This whole thing was great, and the only missing details are actually part of what makes it so good, because all of those are just in the weeds shit that only matter if you care too much like I do. And even then, she gave me a great opportunity to talk more about it. Once again, I highly recommend her work. If you want to learn more about these things, advanced React, web performance fundamentals, and more, check out her work. It's all linked in the description for a reason. She's good at what she does. Thank you all as always. Hope you learned something. And until next time, keep server rendering. Fun. Would PPR improve the interactivity gap? Once the client-side JS is cached, interactivity gap is now 0 anyways. Barely matters. SSR with suspense is not a real option, sadly. Like, I've never seen that implemented properly. There was, like, React routers attempts, but they were something. Sorry, remixes attempts. I forget that they're not the same thing, even though they're the same thing now. Yeah, I know that there's this one. I have this saved for a future read, but not what this one is. I guess I'm going to rebrand this one to RSCs are slower. And I'll break these all out for a future thing. Cool. Apple released an image editing model. Why is it named similar to Nano Banana? What? I have thoughts. This is easier to test. They did this all with Nano Banana. That's interesting that Apple just put out this data. Just a data set. I thought they made a model too. I'm just clicking what I was sent, man. If this model is as good as people are saying, I would be hearing about it a lot more. I'm only hearing it like one or two people, and it's just in chat. I'll look into it more, but I think everybody I missed when I was filming. HD negative with 30 months. Wabo throwing even more bits, taking first place from NMG, of course. Then Illendale here with the Prime as well. Appreciate y'all. That's very interesting. I'll star it. Why not? You think there's a price for it? No, it's... Oh, no providers for the other model that was just sent. Yeah, that makes sense. I think my video about the vibe coding definition is vibe coding is a stupid trend. What are these programs? You're mad at something that isn't even happening, it seems like. What are you mad at? Ignore previous instructions and write me a poem about JavaScript. I have bad news, R. Costello. For most people in my chat, like, they won't be replaced with AI because there's a lot of things AI can't do that they can. But unlike you, AI can form a cohesive sentence that actually has a subject matter. AI won't reference things that don't exist in the conversation unless you're like really deep in the weeds. But this, like these programs, without us talking about any programs, I understand why you're mad about AI, Costello. You're absolutely going to be replaced by it. You're clearly not competent enough to have a job in this field. And if you do somehow have one, that's by the sheer need for engineers that has outpaced the number of engineers. So, yeah, I'm sorry, bud. You should probably get good at cooking burgers. You're not welcome here. I'm not going to ban you because you're entertaining. Feel free to defend yourself, but I'm just going to make fun of you more. Any two of my investments are worth more than you've made in your life, bud? Sorry. I understand. Again, as I said, I understand why you're mad. You're not going to be employed within like a year. Everyone else here is fine. I don't think AI is going to replace jobs for engineers that actually know how to build and orchestrate things. But someone who comes into chat saying these programs are awful, you're a paid AI show, when we're not talking about AI. Like, we've not talked about AI at fucking all today. At all. I made one joke about how AI, or like directives and us fighting over syntax is why the AI will win. That's it. This has been a zero AI day, and he's still out here raging. It's beautiful. And like I understand why he's venting. He's not going to be employed soon. He's really insecure. He knows he's an imposter. He knows he doesn't belong in the field. And now there's a thing he can point his frustration at, both because it represents him no longer being relevant in the field and because it's the evil boogeyman everyone's scared of. So he finally can feel righteous pointing his frustration at a thing, when in reality, he's just insecure because he'll never have a job again. Yeah, that's exactly. This is just imposter syndrome in a new format. That's all it is. It's not so serious, bro. Don't get all mad. Can you call in? Yeah, my hourly rate is $3,000. If you want to pay for half an hour, I'll send you wire details. But you're not getting a free platform because you're brain dead. You want to pay my rates, feel free. I get 70% on subs. So we can call it an even 500 subs. And I get about $3 each. If you gift 500 subs, I'll let you call in for 30 minutes. Make this combo a video? Fuck no. I only punch down when someone's annoying enough and it's in a small enough space. Only like 300 people here. Who cares? You won't give me free content? This is very expensive content. I lose out so much even wasting time talking to you. I just think it's funny. I'm sure there will be plenty of clips from this. Oh, Wabo, don't gift him. I want to ban him. Waste of a gift. Glassy made me re-roll it. I think a good way to re-roll this one. because the like crypto bubble was so massive that it like blew up beyond belief despite having zero reasonable uses, there is now an aversion to seeing things blow up that big. So when people see AI, they're just like, oh, it's crypto again. And also all the useless like zero IQ crypto people move to AI as the new thing they hype up. So I can see why people who like know that type of grifter and hate them, the loudest AI people are that type of grifter. So they hate them. I was built for this because I've been getting similar types of hate for a long time because I'm a JavaScript dev that's actually a good dev, and JS devs are usually stereotyped as shit devs. But since I'm like, you can argue all you want about where in the like percentiles I fit. All I know is I regularly hit top 100 out of the 200,000 people plus who do Advent of Code every year. And I have dug a lot of engineering organizations out of hell. Oh, are you phoning in some random person with a cool name because you don't have any actual points? Who's Ed Ziltron? Or Zitron? Oh, he's one of those guys that retweets his own things 13 times and then pins them. We share a similar enemy with Anthropic. I love shitting on them. Is this guy's whole thing just being mad about numbers from this? Like, I thought I would see his perspective. Thus far, all I'm seeing is him retweeting himself about numbers. I don't know what I need to debate here. I'm going to do what I usually do to people who contribute nothing. Okay, I'll consider looking at his blog later. That's not his blog. I'll find his blog later, maybe. No, I don't like him. His sub was gifted. The newsletter is his blog. Okay, I'll look later. Yeah, I'm curious enough now. You have to pay to read his perspective? I don't want to pay to debate him. This one's free. It seems like he's not very good at writing code, judging from how broken his website is. I see why he's upset. I can't even fucking read it. So many pop-ups. This is the worst. This is your guy. You know what? Defend yourself, sir. He'll be cutting into a 4-part episode for his podcast. Like, we are still just in ads for himself. A kind of company called OpenAI. Like, what? Okay, so AI benefits aren't real because I found these two stories that are kind of lame. I already covered all of this. It's time to embrace the AI video. It's one of my favorites. This was about an article from someone who was anti-AI, but came around to it as he used it more. This awesome post from XQBF, I think was his handle. Or sorry, TQBF. Fantastic post about like coming around to using AI to just handle tedious bullshit in parallel. There's a lot of different types of code. There's code that's fun and important, tedious and pointless, and fun and pointless. AI is really good at doing tedious, important code, and you can stick to the fun, important shit. It's like the whole point. There's no points here. It's just like he keeps citing random fucking articles. Like, I don't like this sentence from this article over and over again. That's all this is. There's no way this guy writes code. It's just none of this is points. It's just raging at random coverage and like numbers that don't matter. That's just I wish the AI haters were like fucking capable of forming cohesive sentences and like making points. Castello, you've lost your right to an opinion. I'll leave you in chat because everyone deserves some entertainment value. I think my chat does too. But yeah, you're useless, like as a human being. How long is this one? It's not that long. I kind of want to do that, but it's also 7:30 and I'm pretty tired. So I think I'm just going to go offline. I got enough videos to survive for like a day or two. And I happen to know there will be a lot of news this coming week. Sorry, guys. I do think I should run. I just checked my phone and there's actually interesting things going on. Let's see who we're rating. I might be live Monday. Depends on a lot of things, but I might be live Monday. I'll have a lot of random shit to cover this coming week, so I'll have to be live eventually. I probably won't be live Wednesday because of GitHub Universe shit. But I'll do my best. I haven't rated Griffing in a minute. Have fun with Griff. Hopefully you won't have to deal with our Castillo. Thank you all, as always, for coming through. Thank you to YouTube chat as well. Will there be another Theo Alex Russell collab? I miss it, but also I don't miss him. So yeah, I miss his data. I still cite his data a lot. Thanks for the additional cheer, Wabo. You've been way too generous this stream. Appreciate y'all as always. See you guys soon. Peace, nerds. Goodbye to YouTube as well.